Soaring in the city of heroes, where champions are made, empowering individuals from all backgrounds to reach new heights. A sanctuary of culture, where heritage thrives. A symphony of triumphs, a testament to our pride, igniting the competitive spirit where dreams collide. From the foundation of education and knowledge, Universitas Negeri Surabaya stands tall as an independent state university. With 5 campuses seamlessly integrated across East Java, Unesa is ready to empower learners from all walks of life on their journey to higher education. At the heart of Surabaya, in the vibrant district of Ketintang, stands Unesa Campus 1. The oldest Unesa's network houses 6 esteemed faculties. Faculty of Mathematics and Natural Sciences, Faculty of Engineering, Faculty of Economics and Business, Faculty of Social Science and Political Science, Faculty of Law, and Faculty of Vocation. Beyond the bustling streets of Surabaya's Lidawetan lies Unesa Campus 2. 7 impressive buildings house a world of possibilities. Rectorate Building, Educational Institution and Professional Certification Building, and 5 esteemed faculties. Faculty of Educational Science, Faculty of Languages and Arts, Faculty of Sports and Health Sciences, Faculty of Medicine, Faculty of Psychology, Professional Education, Graduate School. There are 2 other campuses in East Java. The 3rd campus of Unesa, Confucius Institute, Universitas Negeri Surabaya on Jalan Profesor Dr. Mustopo, Surabaya. The 4th campus of Unesa is located in Gedangan, Sidoarjo. The 5th campus, in the heart of Magetan, East Java, a new chapter unfolds. Unesa's Magetan campus, where knowledge takes hold, with 9 new programs poised to ignite.
Selamat datang di kampus Rumah Para Juara, Universitas Negeri Surabaya. Sebagai perguruan tinggi negeri berbadan hukum, Unesa terus menggali potensi terbaik anak bangsa, menempa para talenta gemilang, dan menjadi kampus yang ramah bagi semua kalangan. Kami percaya bahwa melalui pendidikan, peradaban dapat kokoh berdiri dengan menciptakan ruang inovasi, kreativitas, dan berdaya saing global. Memiliki program studi terakreditasi internasional maupun nasional. Kami berkomitmen memberikan pelayanan dan pendampingan bagi para mahasiswa dalam bidang akademik maupun non-akademik. Manu emprit terbang di angkasa, terbang tinggi bersama rombongan. Ayo bangkit, wujudkan asa, bareng Unesa, satu langkah di depan.
has been accredited as excellent institution, Unesa continues to improve the quality of educational study programs to international standards through ASEAN, ACAS accreditation, and FIBA accreditation, progressively improving the ranking at national and international levels. Universitas Negeri Surabaya also develops various kinds of research and innovative products.
Unesa menyiapkan layanan akademik dan non-akademik. Yang berkaitan dengan akademik itu Unesa tidak hanya memberikan peluang kepada mahasiswa untuk mengembangkan potensi dirinya, tetap dalam bidang akademik saja atau hard skill saja, tetapi juga memberikan peluang kepada mahasiswa untuk mengembangkan dalam bidang non-akademik, soft skill-nya.
Embody the autonomy of an independent university. Unesa, as higher education, provides a variety of business management within the campus area. Unesa has committed in providing excellent service, in supporting learning, preparing qualified graduates in various fields.
Aspek hukum, artinya apa yang dikerjakan oleh Unesa itu harus betul-betul punya dasar hukum yang kuat. Misalnya jam perkuliahan, jumlah beban mahasiswa, jumlah beban SKS itu kita buat aturan hukumnya yang pas. Sehingga kebermaknaannya bagi masyarakat, jika kami mampu melakukan pembelajaran yang berkualitas, tentu akan menghasilkan lulusan yang berkualitas.
As the House of Achievement Champions makes Unesa a center for development exploration soft skills and hard skills.
Unesa telah meraih pencapaian signifikan baik dalam riset pendidikan maupun non-pendidikan. Kemudian, riset kolaborasi internasional merupakan langkah yang terus digalakkan. Pelibatan peneliti-peneliti luar negeri dan hilirisasi dengan dunia industri guna mendukung inovasi produk, teknologi, dan digitalisasi.
Unesa akan memperluas jaringan kerjasama dengan lembaga pendidikan, industri, dan organisasi baik dalam skala nasional maupun internasional. Dengan komitmen bersama, kerja keras, kerja ikhlas, saya yakin upaya-upaya ini akan mampu meningkatkan reputasi dan kualitas Universitas Negeri Surabaya serta memberikan manfaat yang lebih baik bagi mahasiswa, staf, dosen, dan masyarakat luas.
Partnering with various parties, both on a national and international scale. Unesa has recorded its name in the Indonesian Records Museum and reached a number of awards at Dikti Ristek Award 2023. Providing several new students admissions pathways, Unesa opens up opportunities for various circumstances, starting from the National Selection Pathway based on Achievement (SNPT), National Selection Based on Test (SNPT), and Independent Selection (SPMB), which has 7 pathways, makes Unesa as a campus for all people. This hard work will continue to make Unesa a leading, independent, sustainable, and environmentally friendly state university in Indonesia. Soaring in the city of heroes, where champions are made, empowering individuals from all backgrounds to reach new heights. A sanctuary of culture where heritage thrives. A symphony of triumphs, a testament to our pride, igniting the competitive spirit where dreams collide. From the foundation of education and knowledge, Universitas Negeri Surabaya stands tall as an independent state university. With 5 campuses seamlessly integrated across East Java, Unesa is ready to empower learners from all walks of life on their journey to higher education. At the heart of Surabaya, in the vibrant district of Ketintang, stands Unesa Campus 1. The oldest Unesa's network houses 6 esteemed faculties: Faculty of Mathematics and Natural Sciences, Faculty of Engineering, Faculty of Economics and Business, Faculty of Social Science and Political Science, Faculty of Law, and Faculty of Vocation. Beyond the bustling streets of Surabaya's Lidawetan lies Unesa Campus 2. 7 impressive buildings house a world of possibilities. Rectorate Building, Educational Institution and Professional Certification Building, and 5 esteemed faculties. Faculty of Educational Science, Faculty of Languages and Arts, Faculty of Sports and Health Sciences, Faculty of Medicine, Faculty of Psychology, Professional Education, Graduate School. There are 2 other campuses in East Java. The 3rd campus of Unesa, Confucius Institute, Universitas Negeri Surabaya on Jalan Profesor Dr. Mustopo, Surabaya. The 4th campus of Unesa is located in Gedangan, Sidoarjo. The 5th campus, in the heart of Magetan, East Java, a new chapters unfold. Unesa's Magetan campus, where knowledge takes hold, with 9 new programs poised to ignite.
Selamat datang di kampus Rumah Para Juara, Universitas Negeri Surabaya. Sebagai perguruan tinggi negeri berbadan hukum, Unesa terus menggali potensi terbaik anak bangsa, menempa para talenta gemilang dan menjadi kampus yang ramah bagi semua kalangan. Kami percaya bahwa melalui pendidikan, peradaban dapat kokoh berdiri dengan menciptakan ruang inovasi, kreativitas, dan berdaya saing global. Memiliki program studi terakreditasi internasional maupun nasional. Kami berkomitmen memberikan pelayanan dan pendampingan bagi para mahasiswa dalam bidang akademik maupun non-akademik. Manu Emprit terbang di angkasa, terbang tinggi bersama rombongan. Ayo bangkit, wujudkan asa, bareng Unesa, satu langkah di depan.
Has been accredited as excellent institution, Unesa continues to improve the quality of educational study programs to international standards through ASEAN, ACAS accreditation, and FIBA accreditation. Progressively improving the ranking at national and international levels, Universitas Negeri Surabaya also develops various kinds of research and innovative products.
Unesa menyiapkan layanan akademik dan non-akademik. Yang berkaitan dengan akademik itu Unesa tidak hanya memberikan peluang kepada mahasiswa untuk mengembangkan potensi dirinya, tetap dalam bidang akademik saja atau hard skill saja, tetapi juga memberikan peluang kepada mahasiswa untuk mengembangkan dalam bidang non-akademik, soft skill-nya.
Embody the autonomy of an independent university. Unesa, as higher education, provides a variety of business management within the campus area. Unesa has committed in providing excellent service, in supporting learning, preparing qualified graduates in various fields.
Aspek hukum, artinya apa yang dikerjakan oleh Unesa itu harus betul-betul punya dasar hukum yang kuat. Misalnya jam perkuliahan, jumlah beban mahasiswa, jumlah beban SKS, itu kita buat aturan hukumnya yang pas. Sehingga kebermaknaannya bagi masyarakat, jika kami mampu melakukan pembelajaran yang berkualitas, tentu akan menghasilkan lulusan yang berkualitas.
As the House of Achievement Champions makes Unesa a center for development exploration soft skills and hard skills.
Unesa telah meraih pencapaian signifikan baik dalam riset pendidikan maupun non-pendidikan. Kemudian, riset kolaborasi internasional merupakan langkah yang terus digalakkan. Pelibatan peneliti-peneliti luar negeri dan hilirisasi dengan dunia industri guna mendukung inovasi produk, teknologi, dan digitalisasi.
Unesa akan memperluas jaringan kerjasama dengan lembaga pendidikan, industri, dan organisasi baik dalam skala nasional maupun internasional. Dengan komitmen bersama, kerja keras, kerja ikhlas, saya yakin upaya-upaya ini akan mampu meningkatkan reputasi dan kualitas Universitas Negeri Surabaya serta memberikan manfaat yang lebih baik bagi mahasiswa, staf, dosen, dan masyarakat luas.
Partnering with various parties, both on a national and international scale. Unesa has recorded its name in the Indonesian Records Museum and reached a number of awards at Dikti-Ristek Award 2023. Providing several new students admissions pathways, Unesa opens up opportunities for various circumstances, starting from the National Selection Pathway based on Achievement, SNPT, National Selection Based on Test, SNPT, and Independent Selection, SPMB, which has 7 pathways, makes Unesa as a campus for all people. This hard work will continue to make Unesa a leading, independent, sustainable, and environmentally friendly state university in Indonesia. Soaring in the city of heroes, where champions are made, empowering individuals from all backgrounds to reach new heights. A sanctuary of culture, where heritage thrives. A symphony of triumphs, a testament to our pride, igniting the competitive spirit where dreams collide. From the foundation of education and knowledge, Universitas Negeri Surabaya stands tall as an independent state university. With 5 campuses seamlessly integrated across East Java, Unesa is ready to empower learners from all walks of life on their journey to higher education. At the heart of Surabaya, in the vibrant district of Ketintang, stands Unesa Campus 1. The oldest Unesa's network houses 6 esteemed faculties. Faculty of Mathematics and Natural Sciences, Faculty of Engineering, Faculty of Economics and Business, Faculty of Social Science and Political Science, Faculty of Law, and Faculty of Vocation. Beyond the bustling streets of Surabaya's Lidawetan lies Unesa Campus 2. 7 impressive buildings house a world of possibilities. Rectorate Building, Educational Institution and Professional Certification Building, and 5 esteemed faculties. Faculty of Educational Science, Faculty of Languages and Arts, Faculty of Sports and Health Sciences, Faculty of Medicine, Faculty of Psychology, Professional Education, Graduate School. There are 2 other campuses in East Java. The 3rd campus of Unesa, Confucius Institute, Universitas Negeri Surabaya on Jalan Profesor Dr. Mustopo, Surabaya. The 4th campus of Unesa is located in Gedangan, Sidoarjo. The 5th campus, in the heart of Magetan, East Java, a new chapter unfolds. Unesa's Magetan campus, where knowledge takes hold, with 9 new programs poised to ignite.
Selamat datang di kampus Rumah Para Juara. Universitas Negeri Surabaya. Sebagai perguruan tinggi negeri berbadan hukum, Unesa terus menggali potensi terbaik anak bangsa, menempa para talenta gemilang, dan menjadi kampus yang ramah bagi semua kalangan. Kami percaya bahwa melalui pendidikan, peradaban dapat kokoh berdiri dengan menciptakan ruang inovasi, kreativitas, dan berdaya saing global. Memiliki program studi terakreditasi internasional maupun nasional. Kami berkomitmen memberikan pelayanan dan pendampingan bagi para mahasiswa dalam bidang akademik maupun non-akademik. Manumprit terbang di angkasa, terbang tinggi bersama rombongan. Ayo bangkit, wujudkan asa, bareng Unesa, satu langkah di depan.
Has been accredited as excellent institution, Unesa continues to improve the quality of educational study programs to international standards through ASEAN, ACAS accreditation, and FIBA accreditation. Progressively improving the ranking at national and international levels, Universitas Negeri Surabaya also develops various kinds of research and innovative products.
Unesa menyiapkan layanan akademik dan non-akademik. Yang berkaitan dengan akademik itu Unesa tidak hanya memberikan peluang kepada mahasiswa untuk mengembangkan potensi dirinya, tetap dalam bidang akademik saja atau hard skill saja, tetapi juga memberikan peluang kepada mahasiswa untuk mengembangkan dalam bidang non-akademik, soft skill-nya.
Embody the autonomy of an independent university. Unesa, as higher education, provides a variety of business management within the campus area. Unesa has committed in providing excellent service, in supporting learning, preparing qualified graduates in various fields.
Aspek hukum, artinya apa yang dikerjakan oleh Unesa itu harus betul-betul punya dasar hukum yang kuat. Misalnya, jam perkuliahan, jumlah beban mahasiswa, jumlah beban SKS, itu kita buat aturan hukumnya yang pas. Sehingga kebermaknaannya bagi masyarakat, jika kami mampu melakukan pembelajaran yang berkualitas, tentu akan menghasilkan lulusan yang berkualitas.
As the House of Achievement Champions makes Unesa a center for development exploration soft skills and hard skills.
Unesa telah meraih pencapaian signifikan baik dalam riset pendidikan maupun non-pendidikan. Kemudian, riset kolaborasi internasional merupakan langkah yang terus digalakkan. Pelibatan peneliti-peneliti luar negeri dan hilirisasi dengan dunia industri guna mendukung inovasi produk, teknologi, dan digitalisasi.
Unesa akan memperluas jaringan kerjasama dengan lembaga pendidikan, industri, dan organisasi baik dalam skala nasional maupun internasional. Dengan komitmen bersama, kerja keras, kerja ikhlas, saya yakin upaya-upaya ini akan mampu meningkatkan reputasi dan kualitas Universitas Negeri Surabaya serta memberikan manfaat yang lebih baik bagi mahasiswa, staf, dosen, dan masyarakat luas.
Partnering with various parties, both on a national and international scale. Unesa has recorded its name in the Indonesian Records Museum and reached a number of awards at Dikti-Ristek Award 2023. Providing several new students admissions pathways, Unesa opens up opportunities for various circumstances, starting from the National Selection Pathway based on achievement, SNPT, National Selection based on test, SNPT, and Independent Selection, SPMB, which has 7 pathways, makes Unesa as a campus for all people. This hard work will continue to make Unesa a leading, independent, sustainable, and environmentally friendly state university in Indonesia.
Assalamualaikum warahmatullahi wabarakatuh.
Good morning, ladies and gentlemen. Welcome to the second international seminar on physics and its application, ISoPA 2025. My name is Ahmad Midat Ahirumam, and my co-host today is
Abila Maulina. We are honored to be your Master of Ceremony for this inspiring event.
Before we begin, allow us to deliver several important announcements and guidelines. First, all participants are kindly requested to stay off-screen with cameras on throughout the session using the official ISoPA virtual background.
Second, please mute your microphone during the entire seminar, especially during plenary and parallel session. Third, kindly rename your Zoom ID using the format institution_name to help the committee in identifying and documenting attendance. Thank you for being here with us today at
the second international seminar on physics and its application, ISoPA 2025,
with the theme Innovation and Challenges in Physics and Physics Education for a Sustainable Future.
This event is organized by the Department of Physics and Physics Education, Universitas Negeri Surabaya, and supported by Cheers, EduPartner Publishing, and ANDO. And this conference takes place on Saturday, July 26, 2025.
This morning, we are pleased to greet and welcome the Honorable Rector of Universitas Negeri Surabaya, Professor Dr. Nur Hasan, along with all the Vice Rector, the Honorable Dean of the Faculty of Mathematics and Natural Sciences, Professor Dr. Wasis, along with all Vice Deans, Coordinators of the Physics Study Program, Professor Dr. Munasir, and Coordinator of Physics Education Study Program, Mita Anggariani, PhD, the Honorable, our keynote speaker, Dr. Michael Water from Germany, Associate Professor Felipe Hernandez Rodriguez, PhD, from Mexico, Professor Akimitsu from Japan, and Professor Dr. Eko Hariano from Indonesia, and all participants and delegates from around the globe.
Let's begin our first agenda, singing the Indonesian National Anthem. Distinguished guests, please rise for the National Anthem, Indonesia Raya.
Indonesia
You may be seated. Thank you. Before we proceed, let's enjoy a beautiful performance of East Java's cultural heritage. Please welcome the Wanci Kahuripan dance performed by Duria Amiratul Mafudoh, a student of the undergraduate program in physics education. Duria, stage is yours.
ayam kangen kadung kesentor jaman.
Thank you, Duria, for such a magnificent performance.
Now, we will hear a report from the committee chair, Dr. Muhimmatul Khaira. Dr. Muhimmatul Khaira, the time is yours.
Ini oke, 3, 2, 1.
Thank you, Dr. Muhimmatul Khaira, for the insightful report. Universitas Negeri Surabaya, who will be represented by the Vice Rector for Research, Community Service, Innovation, Publication, and University Ranking. For Dr. Bambang Sigit Widodo, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good morning. May peace and blessing be upon us all. Distinguished keynote speakers, honored guests, researchers, educators, and participants. It is a privilege and great pleasure for me on behalf of Universitas Negeri Surabaya to welcome you to the second international seminar on physics and its application, ISoPA 2025. This year's theme, Innovations and Challenges in Physics and Physics Education for a Sustainable Future, is highly relevant in today's global context. Physics plays a vital role in addressing complex challenges, including climate change, energy transition, and technological development. At the same time, physics education must involve to prepare future scientists and thinkers who are capable of critical, creative, and responsible contributions. At Universitas Negeri Surabaya, we are committed to advancing research, fostering innovations, and strengthening global partnerships. Through ISoPA, we aim to facilitate academic exchange, promote collaborative research, and generate meaningful dialogue across disciplines. To our esteemed speakers, thank you for sharing your expertise. And to all participants, I encourage you to engage actively, build connections, and explore new possibilities for future collaborations. I also extend my appreciation to the organizing committee, faculty members, and supporting partner whose dedication has made this event possible. With that, I'm honored to officially declare the second International Seminar on Physics and Application ISoPA 2025 open. Thank you. May this seminar be insightful and inspiring for all of us. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Bambang Sigit Widodo, for the warm and inspiring welcome. The next agenda, Let's Pray Together to answer today's seminar, is filled with blessing. The prayer will be led by Dr. Habibi. Dr. Habibi, time is yours.
لك الحمد كما ينبغي لجلال وجهك الكريم وعظيم سلطانك اللهم إنا نسألك علما نافعا ورزقا طيبا وعملا متقبلا اللهم يا فتاح الأبواب افتح لنا أبواب رحمتك وعلمك وحكمتك اللهم بارك لنا في هذا المنتدى واجعله سببا للخير والنجاة والتقدم اللهم اجمع بيننا على الخير وافرق بيننا على الخير واختم لنا بالسعادة والفلاح اللهم اهدنا الصراط المستقيم ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار وصلى الله على سيدنا محمد وعلى آله وصحبه أجمعين سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين. بسم الله. Thank you and will be success today.
Thank you very much, Dr. Habibi.
Now, we kindly ask all participants to turn on their cameras for the documentation photo session. Please get ready. The operator will count down. Once again, please open your camera for the documentation photo session. 3, 2, 1. Move to the next slide. 3, 2, 1. Thank you for your cooperation.
We will now take a short 5-minute break. The first Keynote session will begin at 9:20. Please stay tuned.
Surabaya, a city associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for exploring and advancing diverse disciplines of knowledge.
Universitas Negeri Surabaya merupakan institusi pendidikan tinggi yang mengembangkan dan keilmuan pendidikan dan non-pendidikan, berkomitmen untuk mencetak insan unggul, menyiapkan lulusan yang tangguh, serta siap menghadapi kemajuan dunia. Fakultas Matematika dan Ilmu Pengetahuan Alam atau FIPA Unesa memiliki komitmen dalam menyelenggarakan pendidikan berbasis teknologi melalui metode pembelajaran inovatif dan berbasis riset sesuai dengan perkembangan zaman. FIPA Unesa telah berdiri sejak tahun 1964 yang bermula dari Fakultas Keguruan Ilmu Eksakta, Institut Keguruan dan Ilmu Pendidikan atau IKIP di Surabaya. Pada tahun 1999 melalui keputusan Presiden Republik Indonesia, IKIP Negeri Surabaya bertransformasi menjadi Universitas Negeri Surabaya dan tetap menjalankan visi utama sebagai lembaga penyelenggara program pendidikan dan non-pendidikan. Saat ini FIPA Unesa memiliki 16 program studi, yakni 10 program studi S1, 4 program studi magister, dan 2 program studi doktor. Seluruh program studi tersebut tidak hanya berfokus pada pendalaman materi kemipaan, namun setiap lulusan juga dibekali dengan soft skill seperti entrepreneurship, kejujuran, kedisiplinan, kreativitas, berpikir kritis, serta inovasi yang solutif untuk memecahkan problem dalam kehidupan bermasyarakat, berbangsa, dan berwawasan global sebagai warga dunia.
Faculty of Mathematics and Natural Science Unesa constantly innovates to help lecturers, academic staff, and students advance their careers. Faculty of Mathematics and Natural Science Unesa must achieve the three pillars of higher education, as well as target and development in various fields. Everyone is encouraged to keep improving their skills through a variety of activities. Faculty of Mathematics and Natural Science Unesa currently employs 27 professors, 45 associate professors, 51 assistant professors, and 46 lecturers. Continuous quality improvement is always a top priority at Faculty of Mathematics and Natural Science Unesa, or CQI. The establishment of quality assurance at the Faculty of Mathematics and Natural Science level to ensure quality while being committed to improving the quality of each action plan carried out by each Faculty of Mathematics and Natural Science Unesa community member realize this commitment. Collaboration is critical in exploring and discovering new ideas and networking to strengthen relationships to achieve sustainable development goals. Faculty of Mathematics and Natural Science Unesa implements Eko Campus programs, such as providing clean and green public spaces, implementing a waste management system, using the reduce, reuse, recycle method, and creating various products to preserve biodiversity to create a green and nature conservation-oriented learning environment. Faculty of Mathematics and Natural Science Unesa is committed to advancing the institution through collaboration with various regional, national, and international agencies. Faculty of Mathematics and Natural Science Unesa prioritizes providing and maintaining various integrated facilities and infrastructure to support all academic community activities. Prioritization of occupational health and safety is also a major concern, as is the provision of various disability-friendly facilities. This effort demonstrates Unesa's seriousness in creating a productive ecosystem oriented to occupational health and safety and friendly for people with disabilities, lecturers, academic staff, and students to support reasoning activities and produce a variety of latest innovation, creative, innovative, and achievements in academic and non-academic fields, both at the national and international levels. Faculty of Mathematics and Natural Science Unesa also facilitates the dissemination of science and technology development by managing scientific journals. All scientific journals covered by Faculty of Mathematics and Natural Science Unesa are open access. Furthermore, Faculty of Mathematics and Natural Science Unesa is committed to the UNESCO-recommended open science movement. Various research findings and ideas are then used in community service projects. This service activity solves various environmental and community problems as part of Faculty of Mathematics and Natural Science Unesa's concern for the community's progress and welfare. Faculty of Mathematics and Natural Science Unesa continues to innovate to turn inspiration into achievement, producing graduates with environmental awareness and an entrepreneurial spirit. It elevates your future with the Faculty of Mathematics and Natural Sciences at the State University of Surabaya. Surabaya, a city associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for exploring and advancing diverse disciplines of knowledge.
Universitas Negeri Surabaya merupakan institusi pendidikan tinggi yang mengembangkan bidang keilmuan pendidikan dan non-kependidikan, berkomitmen untuk mencetak insan unggul, menyiapkan lulusan yang tangguh, serta siap menghadapi kemajuan dunia. Fakultas Matematika dan Ilmu Pengetahuan Alam atau FMIPA Unesa memiliki komitmen dalam menyelenggarakan pendidikan berbasis teknologi melalui metode pembelajaran inovatif dan berbasis riset sesuai dengan perkembangan zaman. FMIPA Unesa telah berdiri sejak tahun 1964, yang bermula dari Fakultas Keguruan Ilmu Eksakta, Institut Keguruan dan Ilmu Pendidikan atau IKIP Negeri Surabaya. Pada tahun 1999, melalui keputusan Presiden Republik Indonesia, IKIP Negeri Surabaya bertransformasi menjadi Universitas Negeri Surabaya dan tetap menjalankan visi utama sebagai lembaga penyelenggara program pendidikan dan non-kependidikan. Saat ini, FMIPA Unesa memiliki 16 program studi, yakni 10 program studi S1, 4 program studi magister, dan 2 program studi doktor. Seluruh program studi tersebut tidak hanya berfokus pada pendalaman materi kemipaan, namun setiap lulusan juga dibekali dengan soft skills seperti ekopreneurship, kejujuran, kedisiplinan, kreativitas, berpikir kritis, serta inovasi yang solutif untuk memecahkan problem dalam kehidupan bermasyarakat, berbangsa, dan berwawasan global sebagai warga dunia.
Faculty of Mathematics and Natural Science Unesa constantly innovates to help lecturers, academic staff, and students advance their careers. Faculty of Mathematics and Natural Science Unesa must achieve the 3 pillars of higher education, as well as target and development in various fields. Everyone is encouraged to keep improving their skills through a variety of activities. Faculty of Mathematics and Natural Science Unesa currently employs 27 professors, 45 associate professors, 51 assistant professors, and 46 lecturers. Continuous quality improvement is always a top priority at Faculty of Mathematics and Natural Science Unesa, or CQI. The establishment of quality assurance at the Faculty of Mathematics and Natural Science level to ensure quality while being committed to improving the quality of each action plan carried out by each Faculty of Mathematics and Natural Science Unesa community member realize this commitment. Collaboration is critical in exploring and discovering new ideas and networking to strengthen relationships to achieve sustainable development goals. Faculty of Mathematics and Natural Science Unesa implements eco-campus programs, such as providing clean and green public spaces, implementing a waste management system, using the reduce, reuse, recycle method, and creating various products to preserve biodiversity to create a green and nature conservation-oriented learning environment. Faculty of Mathematics and Natural Science Unesa is committed to advancing the institution through collaboration with various regional, national, and international agencies. Faculty of Mathematics and Natural Science Unesa prioritize providing and maintaining various integrated facilities and infrastructure to support all academic community activities. Prioritization of occupational health and safety is also a major concern, as is the provision of various disability-friendly facilities. This effort demonstrates Unesa's seriousness in creating a productive ecosystem oriented to occupational health and safety and friendly for people with disabilities, lecturers, academic staff, and students to support reasoning activities and produce a variety of latest innovation, creative, innovative, and achievements in academic and non-academic fields, both at the national and international levels. Faculty of Mathematics and Natural Science Unesa also facilitates the dissemination of science and technology development by managing scientific journals. All scientific journals covered by Faculty of Mathematics and Natural Science Unesa are open access. Furthermore, Faculty of Mathematics and Natural Science Unesa is committed to the UNESCO-recommended open science movement. Various research findings and ideas are then used in community service projects. This service activity solves various environmental and community problems as part of Faculty of Mathematics and Natural Science Unesa's concern for the community's progress and welfare. Faculty of Mathematics and Natural Science Unesa continues to innovate to turn inspiration into achievement, producing bright graduates with environmental awareness and an entrepreneurial spirit. It elevates your future with the Faculty of Mathematics and Natural Sciences at the State University of Surabaya. Surabaya, a city associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for exploring and advancing diverse disciplines of knowledge.
Universitas Negeri Surabaya merupakan institusi pendidikan tinggi yang mengembangkan bidang keilmuan pendidikan dan non-kependidikan, berkomitmen untuk mencetak insan unggul, menyiapkan lulusan yang tangguh, serta siap menghadapi kemajuan dunia. Fakultas Matematika dan Ilmu Pengetahuan Alam atau FMIPA Unesa memiliki komitmen dalam menyelenggarakan pendidikan berbasis teknologi melalui metode pembelajaran inovatif dan berbasis riset sesuai dengan perkembangan zaman. FMIPA Unesa telah berdiri sejak tahun 1964. Yang bermula dari Fakultas Keguruan Ilmu Eksakta, Institut Keguruan dan Ilmu Pendidikan atau IKIP Negeri Surabaya. Pada tahun 1999, melalui keputusan Presiden Republik Indonesia, IKIP Negeri Surabaya bertransformasi menjadi Universitas Negeri Surabaya dan tetap menjalankan visi utama sebagai lembaga penyelenggara program pendidikan dan non-kependidikan. Saat ini, FMIPA Unesa memiliki 16 program studi, yakni 10 program studi S1, 4 program studi magister, dan 2 program untuk memecahkan problem dalam kehidupan bermasyarakat, berbangsa, dan berwawasan global sebagai warga dunia.
Faculty of Mathematics and Natural Science Unesa constantly innovates to help lecturers, academic staff, and students advance their careers. Faculty of Mathematics and Natural Science Unesa must achieve the 3 pillars of higher education, as well as target and development in various fields. Everyone is encouraged to keep improving their skills through a variety of activities. Faculty of Mathematics and Natural Science Unesa currently employs 27 professors, 45 associate professors, 51 assistant professors, and 46 lecturers. Continuous quality improvement is always a top priority at Faculty of Mathematics and Natural Science Unesa, or CQI. the establishment of quality assurance at the Faculty of Mathematics and Natural Science level to ensure quality while being committed to improving the quality of each action plan carried out by each Faculty of Mathematics and Natural Science Unesa community member realize this commitment. Collaboration is critical in exploring and discovering new ideas and networking to strengthen relationships to achieve sustainable development goals. Faculty of Mathematics and Natural Science Unesa implements eco-campus programs, such as providing clean and green public spaces, implementing a waste management system using the reduce, reuse, recycle method, and creating various products to preserve biodiversity to create a green and nature conservation-oriented learning environment. Faculty of Mathematics and Natural Science Unesa is committed to advancing the institution through collaboration with various regional, national, and international agencies. Faculty of Mathematics and Natural Science Unesa prioritize providing and maintaining various integrated facilities and infrastructure to support all academic community activities. Prioritization of occupational health and safety is also a major concern, as is the provision of various disability-friendly facilities. This effort demonstrates Unesa's seriousness in creating a productive ecosystem oriented to occupational health and safety and friendly for people with disabilities, lecturers, academic staff, and students to support reasoning activities and produce a variety of latest innovation, creative, innovative, and achievements in academic and non-academic fields, both at the national and international levels. Faculty of Mathematics and Natural Science Unesa also facilitates the dissemination of science and technology development by managing scientific journals. All scientific journals covered by Faculty of Mathematics and Natural Science Unesa are open access. Furthermore, Faculty of Mathematics and Natural Science Unesa is committed to the UNESCO-recommended open science movement. Various research findings and ideas are then used in community service projects. This service activity solves various environmental and community problems as part of Faculty of Mathematics and Natural Science Unesa's concern for the community's progress and welfare. Faculty of Mathematics and Natural Science Unesa continues to innovate to turn inspiration into achievement, producing bright graduates with environmental awareness and an entrepreneurial spirit. It elevates your future with the Faculty of Mathematics and Natural Sciences at the State University of Surabaya. Surabaya, a city associated with the history of the independence struggle and one of Indonesia's metropolitan cities, is developing into the basis of creative industries and a favorable site for exploring and advancing diverse disciplines of knowledge.
Universitas Negeri Surabaya merupakan institusi pendidikan tinggi yang mengembangkan bidang keilmuan pendidikan dan non-kependidikan, berkomitmen untuk mencetak insan unggul, menyiapkan lulusan yang tangguh, serta siap menghadapi kemajuan dunia. Fakultas Matematika dan Ilmu Pengetahuan Alam atau FMIPA Unesa memiliki komitmen dalam menyelenggarakan pendidikan berbasis teknologi melalui metode pembelajaran inovatif dan berbasis riset sesuai dengan perkembangan zaman. FMIPA Unesa telah berdiri sejak tahun 1964 yang bermula dari Fakultas Keguruan Ilmu Eksakta, Institut Keguruan dan Ilmu Pendidikan atau IKIP Negeri Surabaya. Pada tahun 1999, melalui keputusan Presiden Republik Indonesia, IKIP Negeri Surabaya bertransformasi menjadi Universitas Negeri Surabaya dan tetap menjalankan visi utama sebagai lembaga penyelenggara program pendidikan dan non-kependidikan. Saat ini, FMIPA Unesa memiliki 16 program studi, yakni 10 program studi S1, 4 program studi magister, dan 2 program studi doktor. Seluruh program studi tersebut tidak hanya berfokus pada pendalaman materi kemipaan, namun setiap lulusan juga dibekali dengan soft skills seperti ekopreneurship, kejujuran, kedisiplinan, kreativitas, berpikir kritis, serta inovasi yang solutif untuk memecahkan problem dalam kehidupan bermasyarakat, berbangsa, dan berwawasan global sebagai warga dunia.
Faculty of Mathematics and Natural Science Unesa constantly innovates to help lecturers, academic staff, and students advance their careers. Faculty of Mathematics and Natural Science Unesa must achieve the 3 pillars of higher education, as well as target and development in various fields. Everyone is encouraged to keep improving their skills through a variety of activities. Faculty of Mathematics and Natural Science Unesa currently employs 27 professors, 45 associate professors, 51 assistant professors, and 46 lecturers. Continuous quality improvement is always a top priority at Faculty of Mathematics and Natural Science Unesa, or CQI. The establishment of quality assurance at the Faculty of Mathematics and Natural Science level to ensure quality while being committed to improving the quality of each action plan carried out by each Faculty of Mathematics and Natural Science Unesa community member realize this commitment. Collaboration is critical in exploring and discovering new ideas and networking to strengthen relationships to achieve sustainable development goals. Faculty of Mathematics and Natural Science Unesa implements eco-campus programs, such as providing clean and green public spaces, implementing a waste management system, using the reduce, reuse, recycle method, and creating various products to preserve biodiversity to create a green and nature conservation-oriented learning environment.
Ladies and gentlemen, may I have your attention, please? We are about to begin to the first and second keynote presentation. Once again, here are the reminders. First, please stay on screen and keep your camera on with the ISoPA virtual background. Second, kindly mute your microphone during the session. Third, make sure your Zoom ID follows the correct naming format, institution_name.
The session will be moderated by Dr. Muhammad Satriawan from Universitas Negeri Surabaya. And we are honored to introduce our first keynote speaker, Associate Professor Felipe Hernandez Rodriguez from Tecnológico de Monterrey, Mexico. Professor Felipe and Dr. Satriawan, I will hand over the session to you.
Okay, thank you very much for MC. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Welcome to the plenary session of the International Seminar on Physics and its Application, ISoPA 2025. The Honorable our keynote speaker, Associate Professor Philip Hernandez Rodriguez, PhD, and all distinguished participants and presenters joining us today via the Zoom platform. Hello, Professor. Do you hear my voice? Good morning.
Yes,
Professor.
thank you.
Okay.
Good morning.
Okay. Okay. I am Muhammad Satriawan, and it is my pleasure to serve as the moderator for this session, which will run for the next 14 minutes. Okay. Before we begin, allow me to briefly introduce our keynote speaker. Associate Professor Felipe Hernandez Rodriguez, PhD, is affiliated with Tecnológico de Monterrey, Saltillo, Mexico. He is an expert in robotics and computer vision, holding a PhD in robotics and advanced manufacturing. His pioneering research includes 3D surface recovery using photometric stereo. More recently, he has been at the forefront of integrating extended reality (XR) and metaverse platform into engineering education to promote immersive learning and global collaboration. And today, our keynote speaker will deliver a presentation entitled STEM Education for a Sustainable Future, Immersion, Integration, and Intercultural. Please join me in giving a warm virtual welcome to Associate Professor Felipe Hernandez Rodriguez, PhD. Professor, the time and screens are yours. Please, Professor.
Thank you very much. I will share my presentation and wait a minute, please. I think here. I don't know if I can, I'm not allowed. I think I'm not allowed to share my screen. Oh, yes, now. Okay, well, let's start. Thank you very much for the introduction. As they say, my name is Felipe Hernandez Rodriguez, Associate Professor at the Tecnológico de Monterrey in Mexico. And it's truly an honor to be with you today in the second International Seminar on Physics and Application. I'm grateful for the opportunity to share part of the journey I have undertaken alongside valuable collaborators and our pursuit to transform STEM and engineering education through a more inclusive, sustainable, and ethical models. Just please tell me if you can see my presentation. Can you see?
Yes.
Can you see
Yes,
my presentation?
Yes.
Thank you very much. Well, the work we present today is based on a series of research and pedagogical interventions projects involving more than 400 students in engineering and science, developed in collaboration with some colleagues, academic partners, and international institutions. This approach is structured around three interconnected pillars. The first one is a collaborative approach in which the use of immersive technologies to enhance students' autonomy and engagement. The second one is an interdisciplinary learning focus in real-world projects in industry collaboration. And the last is the development of intercultural and ethical competencies for global scientific citizenship. As you can see here, our pillars is the collaborative approach, working with colleagues, academic partners, and international institutions. Our mission is contributing to a STEM education that is not only technical, but also human and mindful, and the living laboratories in which we have applied pedagogical interventions projects, exploring new ways of teaching, learning, and collaborating. Well, let's go for these interconnected pillars. We talk about the immersive technologies, the interdisciplinary learning, and the intercultural competencies. In this trip, I wanted to talk about three different things, but all of them are interconnected in these pedagogical approaches, in which we are talking about the experience for the students collaborating with people of the school, then taking some specific projects from the physics classes or technical things to hands-on projects in which they can see the benefits of applying the knowledge. Finally, the intercultural competencies, in which we are in a global situation in which we can share with other professionals in the world. Well, the first project I want to tell you, it is about the Keynote simulation project. This is a project management experience in which one of the most significant cases that we are working is this with the Keynote simulation platform developed by a technological partner, we establish an academic alliance. The objective of this project is to provide students with an interactive and playful experience to develop project management skills in a simulated environment. They have to make real-time decisions, manage resources, and they have to adapt to dynamic scenarios in which everything is changing. We implemented this simulation in engineering courses and observe a remarkable increase in student engagement. In perception surveys and structured questionnaires, we find that over the 80% of students reporting feeling more prepared to face real-world projects. And
recording
we
in progress.
25% improve the indicators related to the autonomy of the students and their self-efficacy. This is just an image of that. Sorry, and this is the Keynote simulation. We have this simulator that it is like a game in which they can find different solutions for the different stages that they find in the simulation, but in the exploratory scenarios. We find this very insightful because we simulate with the students and we find that they have the different insights, and then we have different results. They resolve the questions that we want in the quantitative instrument, and well, we find that all the people are strongly agree with the benefits that this kind of scenarios give them. The simulations. Well, this is just an example of that. Then in other project, we talk about the AR manufacturing lab. In this AR manufacturing lab, we find that we explored the use of augmented reality as a strategy for developing self-management learning skills in manufacturing laboratories. The goal of this project is to empower students to manage their learning process more independently and provided them the access to specific technical information directly in the physical practice environment via their mobile devices. The augmented materials included visual explanations, diagrams, step-by-step procedures, and content linked to the laboratory activities. The implementation focused on our students from industrial and mechatronics engineering programs using a mixed methods approach with quantitative and qualitative analysis based on interactions, observations, and reviews. We find, or the findings indicate, that AR supported the development of competencies such as the autonomy, the learning planning, self-regulation, the technical decision-making, especially during the individual laboratory work. These students also reported more dynamic, more accessible, and personally aligned learning experiences with the information that they achieve from the laboratory. And let me just 1 second, please. This is an example of that, of that project in which we use these devices, mobile devices, and we apply that in the laboratory. The thing that we find is that they will be prepared more for the laboratory activities. And well, we use this for different equipment in which they take the information from the machines, and then using the augmented reality strategy, they can achieve information from the machine to learn how to manage them. This strategy starts in the pandemic for obvious reasons, because we cannot go to the labs directly. But with this strategy and the implementation, we find that the students can find the training about the machines and the training about the educational purposes that we want to give to them. And they have very important thing, the self assignments and the self preparation in the laboratory. Okay, well, this, as we said before, this increase the mobility, the mobile integration to access to specific technical information directly for the physical practice environment. This have rich content about visual explanations, diagram, step-by-step procedures linked to the activities, and the target the programs. Well, we have the industrial and mechatronic engineering students working in this kind of experience or this kind of a strategy. These experiences show that when technological immersion is intentional and pedagogically grounded, it becomes a powerful way to foster autonomy, improve technical understanding, and motivate students beyond the screen. This is another project that we use. However, these technologies cannot work in isolation. For learning to be truly meaningful, it must be connected to authentic problems or real-life problems, involve multiple disciplines, and ideally, engage real-world stakeholders. That is, we can discuss in the next project. For example, we have this. This is a raw STEM project, and this is a challenge-based learning with the industry, with the integration with industry. We have here the immersive technologies alone does not transform learning, even the augmented reality or the virtual reality. But what truly makes a difference is how we link these tools to authentic, interdisciplinary, and collaborative problems that challenge students to apply what they know and to discover what they don't. In this second section, well, we will explore about this challenge-based problem. Learning and interdisciplinary collaboration can foster deeper, more meaningful learning, and with some alignation with professional practice. This project about the ROV STEM project is an interdisciplinary design of remote operated vehicle. One of the most enriching projects was the implementation of this ROV STEM, focused on the design and construction of remotely operated vehicles. This is as a strategy to integrate knowledge in interdisciplinary context. The goal was to articulate the competencies in mechatronic and industrial engineering, electronics, programming, and importantly, fundamentally about physics concepts such as force and pressure, buoyancy, hydrostatic thrust, electrical energy, and fluid dynamics. These concepts, often abstract in the classroom, came to life when the students have the opportunity to apply them to real problems. They can ensure that the vehicle's underwritten stability, calculating mass distribution, or determining the torque needed for the propels. This hands-on experience allowed the students to validate and reconfigure their theoretical understanding. According to evaluations, over the 85% of the students reported a better grasp in the involved physical principles. They learned doing the project with noticeable improvements in their ability to explain complex phenomena using empirical evidence for their prototypes. Let me see if I can share with you some of this information. Sorry about the format, but well, this is an example of the ROVs. They study all the physics concepts, and then they build these prototypes, and they work about how it works. They have a competency, have a contest to reach some specific goals, but the most important things, they can understand the physical laws about the buoyancy, about the pressure, about some mechanical things, about fluid dynamics, and this kind of things. This is a context that we perform in the university, and this is very good for the students because they have all the concepts, they learn the physics, but when they build this kind of prototypes, we think that they really understand what is happening with the physics laws and all the behavior of the water, of the vehicle, and all this kind of things. Well, this is just an example of that. Probably we can talk a little bit more in the question and answers. Well, and that's it. Integration focus, physical concepts, and practical application. Another application, or going beyond of these technical skills, we have another project that is about the formative research with real outcomes. We have this new strategy about the technical competencies that give us practical application of theoretical concepts, validation and reconfiguration of theoretical understanding, the explaining concept phenomena using empirical evidences, but we can build professional skills as the time management, the teamwork, collaboration, the technical documentation, the resilience in the face of failure. All of these things give us the opportunity to improve the teaching and learning applications that we perform with our students and in the STEM context. This other one, it is the formative research with real outcomes. And this is another work that we perform we name it as From Challenges to Research Papers. We use the IVL and CURE strategy implementation. And this is to complement the ROV STEM approach that I already showed you. We implement a combined strategy for inquiry-based learning, IVL, and classroom-based undergraduate research experiences. This is the CURE. This is aimed at deepening conceptual understanding and strengthening research skills in engineering and science students. In this model, the students take an active role in the scientific process, from formulating questions to interpreting data and disseminating results. What sets this strategy apart of the direct connection with applied projects, such as the ROV themselves, which serve as experimental platforms for generating original knowledge. At this stage, we invite to the students to perform some research tasks. For instance, In this model, the students take an active role in the scientific process, formulating this question and interpreting the data, as I told you. For instance, based on the challenge encountered during the rough constructions, such as the optimizing buoyancy, balancing weight and thrust, improving system energy efficiency, students design this micro-research projects where they apply scientific methods to validate the hypotheses that they perform and solve the real problems, while learning the basic structures of a scientific paper. Well, the results that we get from this strategy, more than 40 students have an academic product. They generate poster or they generate some abstracts for conferences. They generate complete papers with all the strategy, with all the documentation, with all the things that they can to perform to make some research, and they included this all of these things. Significant improvement was reported not just in the technical approaches, but in the understanding about the concept and how to write it, how to present it, how to explain to others, and this is a very important thing. This significant improvement was reported in skills such as the scientific writing, critical thinking, and data-driven argumentation. In short, this strategy consolidated the hands-on, rough STEM learning experience into a rigorous and academic meaningful research journey. Now, these integrated approaches that I already told you not only enhance the technical learning, but also position the student as active agents of science, yet a world in which they will apply this knowledge in diverse, uncertain, and increasingly interconnected, that why we also need to develop intercultural, ethical, and global collaboration skills. The focus of the next section, it will be the last section, it is about this interculturality. Well, this is about the global collaboration in virtual environments. I wanted to talk to you about the interculturality and ethics in global virtual environments. While this technology that we already described and interdisciplinary challenges are a key or the key to transform STEM education, we cannot overlook the global, diverse, and ethical complex context at which our students will carry out their professional practice. This third axis focuses on the development of the global scientific citizenship that is preparing our students not just to solve technical problems, but to collaborate across cultures, face ethical dilemmas, and act responsibly in complex and distributed environments. This next work that I will share you, it is about the international collaboration. Wait a minute, please. Well, it is about that. This is a collaborative online learning, international learning and metaverse. We use the metaverse to collaborate with other countries. Our students can share impressions. They can collaborate in these platforms to perform some specific projects. This is a strategy of COIL, the Collaborative Online International Learning in the metaverse. A strategy we have successfully developed in the use of this COIL environments and interaction spaces in the metaverse. This experience involved students, and in our experimentation, it was from Mexico and Chile. This is a South America country, Chile, who worked together to solve challenges related to the sustainability, global citizenship, and professional ethics using immersive technologies and enable synchronous encounter in 3D virtual environments. In this COIL Metaverse project specifically, these multicultural teams carrying out the structured collaborative activities, including serious games, thematic debates, and co-designing of shared solutions. These sessions were held weekly in a metaverse platform, accessible through web browsers, and customized 3D spaces designed to foster peer interaction across these cultures. And we have here all the elements that are involved. The international themes focuses some specific focus areas, some activities, and obviously the technology. 75 of the students felt better prepared for the international and multicultural collaboration with these experiences. Well, sorry. Now, we have here the faculty perspective on general, well, no, this is another thing, sorry. We can go directly now to the ethical challenge. And I think that it is a worldwide issue that all of us, we have with the artificial intelligence. But this is a very huge ethical challenge. And we can use it to enhance the learning. But now, global environments don't just bring cultural diversity, they also present new ethical challenges. In this case, a recent example is the use of the generative artificial intelligence in educational contexts, especially in tasks like writing, problem solving, or data analysis. The artificial intelligence gives us all these tools that we can use, but we have to use it responsibly to perform this kind of tasks. In a recent study, we explored how university professors perceive the interaction or the integration of the generative AI in the classroom. And the findings that we have reveal a tension between the potential of these tools to enrich learning and concern about the ethics, authorship, assessment, and equity. Well, these reflections invite us to prepare professionals who are not only competent, but also capable of making informed and responsible decisions in complex technological environments. We have this and the critical need professionals capable of making informed and responsible decisions in complex technology environments. Now, how can we prepare global scientific citizens? Well, they have to be aware, the intercultural awareness. They have to understand and appreciate the cultural difference in a global collaborative environment. We think that the empathy is a very important thing. For this reason, the empathy development for building emotional intelligence and understanding a diverse perspective. The cross-cultural communication is very important, managing linguistic and cultural differences effectively, and international themes. And well, the ethical decision makings. They have to act responsibly in complex and distributed professional environments. Well, this is that we propose these 3 transformative dimensions to integrate this approach to STEM education. Obviously, we have to use the immersive technology as a facilitator of student autonomy and engagement. The challenge-based learning is a very important thing. We already we trust in that strategy. This is the bridge between the theory and practice, the intercultural ethics that give us the foundation of for socially responsible science. And how can we get for our students with these strategies? Well, we can get a more interdisciplinary, inclusive, and globally connected education. Well, some results that we can share about all these applications, the student engagement, the skill development, the global readiness, and the academic outputs. All these indicators or these measures, we already have the increased measurement of these elements. Well, some key lessons learned, and we are closing right now. The intentional design is very important. The technology must be pedagogically grounded, not just digitally impressive. We have to use the tools that we have in our hands to apply in the learning process. Some authentic problems, real-world challenges, engaging students more effectively than simulated scenarios in some cases. The collaborative learning is very important. All the interdisciplinary teams mirror professional practice environments in which the students can develop some other skills, not just the scientific or just the engineering skill or the physical things, but the collaborative learning. The cultural integration is very important. The global perspective are essential for the modern STEM professionals because we have to go or to see beyond our countries. We have to collaborate. We have to work with other people and to improve our techniques. And the ethical consciousness is very important. Technology adoption requires continued ethical reflections and adaptations. Some future directions, well, the evolution of the technology is a fact. We have to integrate this technology in our learning process. The integration for the artificial intelligence, all the advanced techniques of learning environments are the virtual reality or augmented reality, all the predictive learning analysis with data analysis and all these kind of things. The global expansions of our horizons are very important. The multi-institutional partnerships, working with other people, with other countries, with other cultures, and this is very, very important. We have to apply a sustainability focus. We have to develop frameworks for sustainable STEM education that can adapt to changing technological and social landscapes. Well, some questions for reflections and almost finished. For educators, we can think about how can we balance technology innovation with pedagogical fundamentals in our teaching practice. The old schemes of learning probably work, but the world is changing and the technology is over all of us. We have to use it in our purposes. For the institutions, probably what infrastructures and policies we need to support this interdisciplinary, globally connected STEM education, if the institution gives us the support for performing this kind of strategies. And for the students, how can we or how can you take ownership of your learning while developing global citizenship skills? For the society, what role should ethical considerations play in the rapid advancement of educational technology? Well, these projects that I already told you have been more than pedagogical interventions. They have been living laboratories where our students, teachers, and external partners have explored new ways for teaching, learning, and collaborating. My final invitation for us is to continue designing environments where our students not only acquire knowledge, but also develop commitment, develop agency and global awareness. Because education in STEM is not just about preparing professionals, it is about shaping citizens capable of transforming realities. Thank you very much for your attention. I will be glad to continue the conversation about these experiences. And if you have any questions, please go ahead.
Okay. Thank you so much, Professor, for your inspiring and insightful presentation. Your exploration about rethinking STEM education for a sustainable future, immersion, integration, and interculturality has opened up exciting perspective for innovation in physics, education, and applied science. I got a point. Professor Philip underscores the importance of transforming STEM education through immersive technologies, global collaboration, and challenge-based approaches to prepare future professionals as critical thinkers, ethical innovators, and contributors to achieving the sustainable development goals. Now we would like to open the Q&A session for 2 questions. To all the participants and presenters, if you have any question, please feel free to raise your hand or type your question in the Zoom chat box. I will read the question aloud and invite Professor Philip to respond it. Let's begin with the first question. Okay, Mr. Rahman Eka Cahya. Okay, please, Mr. Rahman.
Yes, good morning, sir. My name is Rahman Eka Cahya. I am the master student of physics education in Universitas Negeri Surabaya. Thank you, sir, for your presentation. It gives me a lot of new knowledge. And according to your previous slide, for educators, how can we balance technological innovation with pedagogical fundamentals in our teaching practice? As we know, in Indonesia, especially, I am a teacher as well for senior high school students. It is, to me, a little bit difficult to teach STEM to my students because of a lot of lack of the students like the tools, the room, or everything. And my questions today that I would like to ask you now is it possible to develop STEM in any various way for a universal student, not only in senior high school, or is it possible to develop it in lower level, like junior high school, elementary school, and we still maintain the science or physics concepts? That is my question, sir. Thank you very much.
Okay, thank you so much, Mr. Rahman. And then maybe directly, Professor Philip, please respond the question from Mr.
Yes.
Rahman.
Thank you, Professor, for your question. It's a very interesting thing, because sometimes we think that in a professional grade or a university level we have more tools or more possibilities to work with STEM, but in fact, the curiosity of the students of low levels, I think that it is high curiosity. They want to know why the things are happening, and they are curious about the phenomenon in the world. I think that we can focus our attention to the things that we can see in the nature. We can see some specific phenomenon in our houses. We can see any phenomenons in the nature, and we can just talk a little bit about that and to find explanation about it, and to let the students to imagine, to let the students to argue, what do you think about this? And then when they have this imaginary answer, probably we can go to the basis and say, okay, this thing that you saw in the park, it is the same thing that we talk about the mass. Can you see how this is working in the nature? Now, take this as an example and relate to the mathematics, to the physics, to the chemistry, to the things that they can learn in a book, but they can saw it in the nature, in the houses, in the faucet of the fall of water. They can see there the laminar fluid and the turbulence, and with a cigarette or the smoke or something like that, they can see the turbulence. They can see, well, this kind of things that we teach about the book. Probably we can find the similarities in the nature. I think, or at least it is working for me, even in university, to relate the things that they are common for them with the book. And it is very, very, very interesting. I think that the thing is to find the interest of these students and to achieve the matching of the literature and the observation. at least this is the scientific process, isn't it? We have to observe and then to measure and then to prove and then to write a hypothesis, and this is the scientific process. Probably if we apply this for our younger students, it will be more insightful and probably it will be fun. I don't know if I answered your question. Thank you very much.
Okay, thank you so much, Professor. That answered the question from Mr. Rahman. Okay, we will go to the next question. Maybe there's anyone want ask. If there is no, I will read in the chat box. Okay, Mr. Habib, please, Mr. Habib.
Okay, thank you very much. Good morning, everyone. Good morning, Professor Felipe. I have a question. Digitalization in learning must be linked to contextual aspect of daily life. How can we effectively connect augmented reality to real-world physics application? In my opinion, using augmented reality make it somewhat difficult to bring learning to the real world. Thank you very much.
Okay.
Yes, thank you for your question. I can tell you something that it was not my project, but I saw this application of augmented reality about physics with another professor. This professor used the devices and then put the augmented reality in a specific place. The principal approach that he wanted to reach is about the parabolic behavior of a bullet, and with some parameters about the initial velocity, the inclination, and all these kind of things, he reproduced virtually the bullet, the behavior of the projectile, and then the students built a prototype to shot this bullet, and then they put the augmented reality application, and then they prove that the bullet followed the same path. This is a very simple application because probably they prefer to observe and then analyze, but when the students saw that it is very similar and the curvature of the bullet, it is the same as the augmented reality proof, it is like the head explodes, because they prove that mathematically, because they is calculated, mathematically is the same that physically. This is a very simple thing, but in our case, in the case that I presented to you, and sorry for not present more images or videos, but in the application that I performed for the augmented reality, it was to learn how some specific machine works. Because the process to have 40 students in the same laboratory is very, very clouded. But if you give to them these tools, they can learn by themselves, and they don't need the teacher 24 hours a day, but they can learn about the applications. And well, in the academic field, these technologies give us this possibility. They can experiment, they can learn by themselves, they can explore the different possibilities, they can change the parameters, and they can see what is happening if they play a little bit with this technology. And well, I think I'm sure that it is a little bit difficult, but there is a lot of free apps that the students can use, or different strategies that they can use with augmented reality. I don't know. I'm so sorry. I don't know if Indonesia you have this amount of different apps to available for free for the students, but in fact this is just to experiment, to play a little bit with them, and probably we will find one specific app that gives us the elements that we need to prove something with the students, and that's enough because they will enjoy the experience. Thank you, Muhammad.
Okay.
Thank you very much.
Okay, thank you so much, Professor Philip. Okay, for all the participants and presenters, because due to limited time, maybe questions in the chat box. I have three questions, Professor. Maybe we will send to your email, and then you can respond through your email. Okay, so.
Of course.
Okay. So once more, thank you so much, Professor, for your outstanding keynote address and the thoughtful response during the Q&A session. Your insights have enriched today's discussion and inspired all of us to further explore the intersection of physics, technology, and education. With that, we conclude the first keynote session. See you, Professor. Okay.
Thank you very much.
Yes. We will now proceed with the next agenda item. And now, ladies and gentlemen, I would like to return to the Master of Ceremony to hand over certificates to our keynote speaker, Professor Philip. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Felipe and Dr. Satriawan, for a valuable and inspiring presentation. Thank you, Professor Felipe and Dr. Satriawan, for a valuable and inspiring presentation. At this moment, we would like to invite Dr. Satriawan to officially present the certificate to Professor Felipe. Dr. Satriawan, stage is yours.
Okay. On behalf of the organizing committee, we are honored to present this certificate of appreciation as a token of our gratitude for your valuable contribution to the International Seminar on Physics and its Application, ISoPA 2025. Thank you so much, Professor. See you for the next time. Thank you.
Thank you very much.
Now, we move to the second keynote speaker, Professor Akimitsu from Kochi University of Technology, Japan. This session will be moderated by Mr. Ercizario Edo Yunata, PhD, from Universitas Erlangga. Professor Akimitsu and Mr. Edo, time is yours.
Oh, okay. Sorry. Can you hear my voice? Okay. Sorry.
Yes, I can hear.
Okay. So, good morning, everyone. The Honorable Committee of the ISoPA and the Honorable of the keynote speaker and all of the committee member. So continue to the next step is the second keynote speaker, and I will invite Professor Akimitsu from Japan before he deliver his speech about his topic today. I would like to tell to you about the brief CV from Hata Sensei. So Hata Sensei is professor from Kochi University of Technology, Japan. So his specialization in the plasma science and engineering, electric and electronic material, energy and environmental education. So now, currently, the Hata Sensei is the Vice President Education of Kochi University of Technology. And the academic society from Hata Sensei is a Japan Society of Applied Physics, the Illuminating Engineering Institute of Japan, the Institute of Electrical Engineering of Japan, the Institute of Electrostatic in Japan, and then Japan News Diamond Forum, and then the Material Research Society of Japan, and then the last is a Japan Association of Energy and Environmental Education. So now the contribution to the local community from December 2010 until 2018 is the committee member of Board of Education Kochi Prefecture. Good morning, Hata Sensei. Can you hear my voice?
Good morning. Thank you for the kind invitation.
Okay. So, Sensei, the presentation will be 30 minutes and then followed by the question and answer. Now, time is yours.
Thank you. May I share my slide?
Yes, Sensei, please.
Can you look my slide?
Yes.
Okay.
Okay.
Let me start my talk. First of all, I'm very happy to join this big conference in Indonesia. So congratulations on this second international seminar on physics and its application, ISoPA 2025. I'm very honored to have this opportunity to speak at this seminar, in which bring together people working with physics and applied physics and physics education. Here, I'm in Shikoku Island. I'm in Shikoku Island here. And my university is Kochi University of Technology. It's a local government public university. Today, we have also physics-related academic society in Okayama. It's a JSAP, Japanese Society for Applied Physics branch meeting. So now in Okayama, and I just find a small room to share your conference. So it's a very interesting experience to make such an important speak through the internet. So this is the introduction of Kochi, because the Kochi city is the center of Kochi prefecture. It has sister cities of Surabaya. So I heard Yosakoi dance is also played in Surabaya. The original Yosakoi Dance Festival will held 2 weeks later in Kochi. It's very exciting dancing festival. Everyone dance on the street and the shopping mall. I really agree with this subtitle of this seminar. It's very interesting. Innovations and challenges in physics and physics education for sustainable future. I'm convinced that the exploration of physics and application of physics and physics education are the key to realizing a sustainable future. I also, in 2005, we established the Japan Society of Energy and Environment Education with many researchers and teachers working on energy and environmental education. Toward a sustainable future, I specialize in electronic engineering myself, but we also have researchers in physics and also education and social academics and economics, and as well as many teachers from elementary school, junior high school, and high schools. So we have not have any international activities now, but in future, we can collaborate some Asian countries to develop this activity. Here, I want to introduce some important idea of the energy and environmental education. This is not my main topics of today, but I want to show because of this seminar's subtitle. One of the important ideas is we call 3E trilemma. 3 trilemma means 3 different sections, 3 different issues are simultaneously solved. So one is the energy security. In Indonesia, maybe Indonesia has a very much amount of fuel resources, but we Japan not so much resources. So it's very difficult to find some energy security. Next E is economy growth. And the third one is environmental protection. For example, if we use energy, it affects the environment. Or if we want to keep natural environment, we need to save the energy. Or we use some different kind of natural energy. In both cases, we need money to start. So these 3 ideas is very important to balance out. I can say also SDGs. SDGs is the Agenda 2030 determined by the United Nations. It's also the same idea, social and economic and environment. These 3 aspect issues sometimes conflict. So we have to find any balance out of these 3 issues. It's an important idea. Another idea is education of energy itself. First, I want to introduce the definition of energy. Of course, all of the participants are very well know about the energy in physics. But sometimes we have some problem because physics textbooks in junior or senior high school in Japan, they start from the force. Force times traveling distance, it makes work. So it's the integrating force over space, we can get work. Then we teach if we differentiate work with time, it makes power. This story is little bit complicated. So many students confusing force, work, and power. Sometimes they cannot understand exact meaning of power. So in our society, in our education society, we start a new idea. We can start from power. Because if we integrate power over time, it will make also work. So both the way, from force to work, from power to work, it's a good approach to understand energy. For this idea, we start to develop high performance human powered generator to feel how much power we can make by generating electricity. So this is the human powered generator we made and maybe 20 years ago, because it's difficult to measure energy itself. Because energy can be compared to the amount of fuel. For example, a couple of tanker, it's a huge amount of energy. But we cannot feel reality. How much big, we cannot understand. Instead, power can be experienced by ourselves. We can feel the power by generating electricity by ourselves. For example, we can get food energy. We usually eat 2,000 kilocalories per day. If you calculate transfer calorie to joule and count the seconds per day, it's almost 100 joule per second. It means 100 watt. So basically, we get 100 watt energy from food. Then we usually use basal metabolism for 60 watt. So remained 40 watt, we can make work. But actually, during sleeping, we don't use this. So daytime, we can expect more than 40 watt. Maybe nearly 100 watt we can make. So we defined one human power equal 100 watt. It's not exact number because of it's different for the personality, but almost average is this value. So 0.1 kilowatt is one human power. Previously, we used 1 horsepower for the unit. Now it's 750 watt. So it's very similar. 1 horsepower, we sometimes put 1 HP. But now we use 1 HP as 1 human power as 100 watt. Then we can show the energy for work is this power times time. This shows the actual characteristic of human power. This is by our students, university students. They try 30 minutes power generation. At first, about 10 seconds, it's very huge power. 400 watt or sometimes 500 watts. Such instantaneous power cannot continue so long time. If they continue the power generation, it's gradually decreasing, and finally, it's below 100 watt. I also ask another students to try to make electricity, and by his electrical power, he enjoyed movie watching. He drive DVD player and small TV by himself, and he enjoyed 1 hour movie by himself. At that time, about 50 watt. He said, it's not difficult. It's okay. He can enjoy anytime. 50 watt movie theater. It's a very interesting topic. Okay, so this topic is very interesting, but I must go to my main topics today. This is my title. A novel method for producing gas discharge plasma using photocathode. My contents include research on plasma and application. One is plasma fusion reactor and semiconductor device manufacturing. Also, medical or bio and agricultural application at atmospheric pressure plasma. And proposal of this novel discharge method using a photocathode and its experimental verification. So first, most of you already know this big challenge. This topic is perfectly match today's seminar because it's just a challenge for our future. This is the challenge of realizing plasma fusion as an energy source. That will support our sustainable future. This is a mission, very important mission we have to challenge. I look forward to this ITER apparatus. Now it's building, but in this 5 or 10 years, it will start to experiment. I don't know it's successfully can be operated to make electrical power. But in future, we have to succeed to get energy from atomics. I believe we have to stop the nuclear weapon, but we have to study and develop the peaceful use of nuclear energy. Another important field of plasma is a semiconductor manufacturing process. This slide is from Tokyo Electron Company. This company is producing the semiconductor device, not semiconductor device itself, but the fabrication system for the semiconductor. This photograph shows the very deep etching they succeeded. The size of this hole is about 100 nanometer, 0.1 micron. The depth is 10 micron. So the aspect ratio is more than 100. They succeeded to operate this etching by 30 minutes. 30 minutes is a little bit long time for the industrial use, but it's become a very important technique to static memory devices, NAND devices. They succeeded. Also, some other material processing, for example, plasma, chemical vapor deposition, or sputtering, and this etching. It's very widely used in industry for manufacturing semiconductor devices. The next 3 slides, these are provided by Professor O, JSO, from Osaka Metropolitan University. He was a collaborator in my laboratory as a postdoc researcher nearly 5 years ago or 10 years ago. Now he is a professor in Osaka Metropolitan University. And he succeeded so many results about medical application of plasma. Usually, for conventional gas discharge, we use very low pressure or vacuum. But about 20 to 30 years ago, Professor Okazaki in Sophia University in Tokyo succeeded to operate such a stable plasma in atmosphere. It's very big impact. We can operate plasma in air. This is we call plasma jet, helium plasma jet. So we can get helium ion or excited helium. And also in air, we can make some chemical reactive species, oxygen radical, oxygen ion, OH, O2, also NO and NO2. Many kinds of reactive species we can make. And some of these species are very effective for the human body or bio. This is experiment to irradiate plasma to the tumor on mouse. The upper slides show the control of helium gas flow. If we applied helium gas flow, helium gas jet, it's no effect. But if we applied helium plasma jet, we can get oxygen reactive species inside of the mouse body. So it gets into the body and many effects. So they already found some of the tumor decrease by plasma irradiation. This is also the topics by Professor Ho. He succeeded to find bone regeneration induced by plasma irradiation. So they make intentionally broken body, broken bone, then they irradiate helium plasma jet on the surface. And they change the power density and the radiation time. Finally, they found some good condition exists for the acceleration of degeneration of bone. It's also very interesting. But in this moment, we don't know the real actual mechanism. But anyway, we can find some interesting result in this kind of medical area. This slide show also the medical application. One is the very slight burning by the plasma. It makes very clear surface after surgeon cutting. And also, some people use Petri dish of the plastic. Basically, the surface of Petri dish, original material, has the not water, not good for water surface. So, hydrophilic surface. So, they irradiate plasma on the surface and they succeeded to make hydrophilic surface. So, it's very effective. Maybe someone already used this material for experiments. So finally, I must go my main topics. And this slide is by Dr. Sukuma Y.U. Fitriani. And I presented in JSAP 2 years ago. It's a Japanese Society for Applied Physics meeting. Sukuma was my student, and she was from Brawijaya University in Malang. So I visited Malang once or twice. Unfortunately, I skipped Surabaya, unfortunately, at that time. So this is the background of my research. So first, I found Professor Takahabayashi and Takakua's journal paper. This is the interesting trial to irradiate very intense UV light to the plasma chemical deposition area chamber. It's a very intense xenon excimer lamp. Xenon excimer lamp has the 172 nanometer wavelengths and 7.2 eV photon energy. It's extremely high and also very high power density, several 10 or nearly 100 milliwatt per square centimeter. So I found it's very interesting trial. So I think it can be applied to the atmospheric pressure discharge. But if we use conventional technique, UV go to the air, that 172 UV is easily absorbed by oxygen, and it will make amount of the ozone. So see, this style is not effective. So I considered to irradiate the cathode, photocathode from backside, and passing through some UV light will make the photo emission. We studied some previous works. We found so many works to use back illuminated photocathode. But most of these activity use very long wavelengths because in this time, they cannot use such the high energy UV light. I also find Japanese researchers already use back illuminated light for gas discharge. But at that time, they use hydrogen discharge for UV source. The current level is 1 picometer, 1 picoamps to 1 femtoamps. It's too small to discuss about the discharge. But in our research, we can get very, very high intense UV light. We can get microampere current. So it's quite different. So this is a little complicated. I want to skip. So then we set this kind of apparatus. This is photography of experiment. It's very simple, just a glass plate and fixed by the clip. On this glass, this is quartz glass. We put gold, very thin film. And from backside, we irradiate by UV light. With spacer, and we use anode aluminum plate. We get discharge area here, and we applied voltage, and we applied UV light. And we put, we flow the gas, air, or helium, nitrogen, or argon. The exit of the gas tube is open to air. So this is the atmospheric gas discharge. So first, we check the optimization of the gold thickness. If the thickness is too thick, we cannot, the UV light cannot penetrate. If we use very thick gold film, it cannot be absorbed, completely transparent. So we find some optimum thickness. We found about 9 nanometer is the best thickness. And at that thickness, the transparency is about 50 to 60%. And the conductivity rapidly increase at that time. Then we applied voltage and UV light. Then we get voltage and current relationship. If we don't use UV light, no current. If we apply UV light with voltage, we can get very big current increase, about 40 or 50 microns. This is the UV power density. If we change the UV power density, the current level is different. It's very easy to understand because the UV light excites the electrons, photoelectrons, and it makes discharge. So discharge current just depends on the UV light intensity. We also change the UV source for 255, 254 or 265, but at that kind of long wavelengths, the quantum efficiency is too small, so it's not effective. So due to time, I go to this final slide. This is possible application of such atmospheric air plasma. So in the introductory talk, I introduced the helium plasma jet. It's use huge amount of helium gas. It's quite difficult to apply. But in our technique, we can use only air. The surrounding air just pump into the discharge tube. Then we can get some chemically reactive species, NO2 or NO3 or OH. We put into the water to bubbling, and then we get the UV absorption spectroscopy to confirm what kind of materials produced in the plasma. And we succeeded to get the selective production of NO2 material. Okay, due to time, I have to summarize my talk. My summary is this sentence. So, in this conference, very good subtitle I found. So, physics and physics education for sustainable future. So in my talk, I introduced we developing a novel discharge method using a hot cathode and also aiming to pioneer applications. These topics, photo emission discharge was inspired by the physical phenomena of photo emission and also the understanding of gas discharge mechanism for plasma generation, and also the recent development of high-intensity UV light source called the excimer lamp. So, such the new ideas are born from learning about various physical phenomena in literature or in history, and also following up the latest technological innovations. I hope your physics research or your physics education will develop into innovations that will support our sustainable society in future. Thank you for your attention.
Okay, thank you, Sensei, for your insightful and engaging presentation. We truly appreciate the valuable knowledge and perspective you have shared with us. And all of the participants, if you have some question, you can typing in the chat, or you can raise your hand icon, so we can move to the question and answer section. Thank you, Hatta Sensei.
Thank you very much.
Is there any question? Okay, Sensei, there is some question. I will read for you. So this is from Ana Nadiro. So she asks about, hello and good morning, Mr. Akamitsu. My name is Ana, a physics education student. I like to inquire about your paper entitled A Novel Method for Producing Gas Discharge Plasma Using Photocathode. So my question is, what is the potential for the photocathode method to be integrated into industrial scale system, given the smaller discharge current compared to glow discharge? Okay, that is the question, Sensei.
Today, I introduced the first experiment. We use very small UV light source. It has a 20 milliwatt per square inch. It's a very limitation of the UV light intensity. But we already get much bigger power density UV light source. It's 300 milliwatt per square inch. Then we hope we can increase the current level 1 or 2 orders. Then it would be almost same amount as the conventional glow discharge. So if we get same plasma as glow discharge, it's not interesting. But if in the conventional glow discharge, due to the mechanism of glow discharge, the glow discharge has the positive column and cathode wall structure, and it is limited electron energy and electron density due to discharge mechanism itself. But I hope by using photocathode, we can increase the current by just increasing photon energy, photon power. And also, we can apply any voltage to accelerate the electron. So we can control electron density and electron energy independently. It's a novel technique to control the plasma reaction. Is that okay?
Okay. And then there is one question more, Sensei. So this is from Moza Pinkan. He asks, how does the long-term operational stability of the gold thin film photocathode compare to the conventional electrode in plasma-based application?
Good question. Actually, we don't know the very long time experiments. We just try 1 or 2 hours. It's almost no effect because the conventional gas discharge, the cathode is damaged by ion attack on the surface. We usually say sputtering of the cathode. Very heavy ions attack on the cathode material dispersed. But in our case, we don't use such the ion impact. We just use photo emission. So it's more stable, we hope. But the problem is the gold film is too thin. So if we continue discharge, we need to afraid that the surface structure of the gold surface will change due to the plasma irradiation. In this moment, no problem. Instead, we have to consider the excimer lamp. Actually, the excimer lamp has the 1,000 or 2,000 hours lifetime. So it's more serious for us.
Correct. Yes.
But in
Understand.
future, I hope the solid state LED UV light source also makes such a very big energy and big power intensity in future. So in that case, we can change from the gas discharge lamp to the LED. Okay.
Okay. Sensei, I have a question. One question for me. So, what is the main challenge to build the atmospheric pressure plasma? What is the main challenge, or maybe sometime often happen when we want to build the atmospheric pressure plasma, Sensei?
Sorry, once again, atmospheric pressure.
What is the main challenge when we want to build the atmospheric pressure plasma?
Atmospheric pressure, helium plasma jet is very stable and very easy to operate. So it's widely already used. The most difficulty is the usage of helium gas.
Okay.
One cylinder is used in few hours. So it's very expensive.
Very expensive, I see.
So we want to decrease the helium, or we don't want to use helium. It's challenging.
Okay. Sensei, there is one question more. Maybe this is the last question, I think. So, is there any possibility that we can make a low-cost plasma without using gold? Are there any other material to could replace the gold? Because in Indonesia, a little bit hard to find the gold as experimental material.
Okay. The research on the plasma, previously, we needed to use vacuum system. The vacuum system costs very high, really. But now, I don't use vacuum system so much, because mostly we use atmospheric pressure. So in our case, not so many expensive material, just a quartz glass and UV light and conventional high voltage source. So if you want to try, you need to just get UV light source, but such a small lamp is not so expensive.
Okay, Sensei, thank you for your question and for your sharing about your research topic. It's very insightful. Okay, move to the next step is committee. Can you tell to me?
Thank you, Professor Akimitsu and Mr. Edo, for the insightful talk and discussion. May all of us gain knowledge and benefits from both presentation. At this moment, we would like to invite Mr. Edo to officially present the certificate to Professor Akimitsu Hatta. Mr. Edo, the stage is yours.
Okay, thank you very much.
Hi, Sensei, thank you. So this is the certificate that we can appreciate to your sharing knowledge to ISoPA Conference 2025. We
Thank you very
truly
much.
appreciate your coming. Thank you, Sensei.
Next time I want to visit Surabaya.
Okay, no problem. Okay, I will waiting for you. Thank you, Sensei.
See you.
Now, we will take a short break and we will reconvene for the third and fourth keynote speech.
saatnya tak lagi berpangku tangan. Unesa berkarya untuk negeri Indonesia. Yakin kita pasti akan bisa meraih asa menggapai cinta. Sing-singkan lengan, pandanglah ke depan, kobarkan semangat dalam dada. Terus berkarya selagi bisa, tak mudah lelah dan putus asa. Bergandeng tangan, satukan upaya, Unesa satu langkah di depan. Satu kata, hidup ini perjuangan. Tapi Tuhan selalu ada untuk kita. Jangan ragu lagi, asa, ilmu, iman, takwa. Demi satu kata, Unesa satu Indonesia. Yakin kita pasti akan bisa meraih asa menggapai cita. Sing-singkan lengan, pandanglah ke depan, kobarkan semangat dalam dada. Terus berkarya selagi bisa, tak mudah lelah dan putus asa. Bergandeng tangan, satukan upaya, Unesa satu langkah di depan. Jayalah Unesa, satu langkah di depan. Unesa satu langkah di depan. Bukan hanya menunggu mimpi kan datang, bukan pula menyerah pada prahara. Inilah saatnya tak lagi berpangku tangan. Unesa berkarya untuk negeri Indonesia. Yakin kita pasti akan bisa meraih asa menggapai cinta. Sing-singkan lengan, pandanglah ke depan, kobarkan semangat dalam dada. Terus berkarya selagi bisa, tak mudah lelah dan putus asa. Bergandeng tangan, satukan upaya, Unesa satu langkah di depan. Satu kata, hidup ini perjuangan. Tapi Tuhan selalu ada untuk kita. Jangan ragu lagi, asa, ilmu, iman, takwa. Demi satu kata, Unesa satu Indonesia. Yakin kita pasti akan bisa meraih asa menggapai cita.
Ladies and gentlemen, may we have your attention please? The third and fourth keynote session is about to begin. Please take your seat and get ready. Here are some quick reminders. First, please remain on screen and turn on your camera using the ISoPA virtual background. Second, ensure your microphone is mute. And the last, rename your Zoom ID to follow the committee's format.
This session will be moderated by Dr. Muhammad Anas Thohir from Universitas Negeri Malang. Let us welcome our third keynote speaker, Professor Dr. Eko Hariano from Universitas Negeri Surabaya, Indonesia. Professor Eko and Dr. Anas, the time is yours.
You hear me?
Yeah.
Okay. Thank you, Master of Ceremony, ladies and gentlemen, honorable distinguished guests, participants, presenter, and keynote speakers. Good afternoon and welcome to the keynote speaker session of our conference, the second International Seminar of Physics and its Application, ISoPA 2025, titled Innovation and Challenge in Physics and Physics Education for Sustainable Future. My name is Anas Thohir, and I will serve as your moderator for this session. We are truly honored to be joined by an esteemed keynote speaker who has made significant contributions to science education, disaster risk education, and sustainable learning. It is my great pleasure to introduce our keynote speaker. Hello, Professor Dr. Eko Hariano.
Halo, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, well, I would like to read a brief CV of Professor Dr. Eko Hariano. Professor Dr. Eko Hariano is a full professor and currently serves as head of master's program in science education at Universitas Negeri Surabaya, Indonesia, with over 2 decades of experience in science education. His expertise lies in Q-science education, disaster risk reduction, STEM integration, and education for sustainable development. He earned his doctoral in science education from Universitas Pendidikan Indonesia, where he focused on developing the Vulcano-Learn project and innovative model to enhance disaster awareness through Q-science learning. Prof. Eko have been actively involved in numerous national and international research projects, particularly in promoting scientific literacy, environment awareness, and sustainable education practice. He has published more than 60 international journal articles, so many, contributed to 10 books and book chapters, and holds several rights related to science education and innovation. He has also been invited to speak at various global forums, including UNESCO's webinar on disaster education and climate literacy, and is a key member of international research terms such ESD and ATACCE. Today, Professor Eko will deliver his keynote speaker titled STEM Education for Sustainable Development, an effort to innovative physics teaching and learning process in the new era. Well, without further ado, please join me in welcoming Professor Dr. Eko Hariano. Professor, the screen is yours.
Okay, thank you, Pak Anas. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
All participants, all committee members, this one is fourth moment for me to join in the wonderful event, ISoPA. Congratulations to all members. You succeed to conduct good conference today. I'm very honorable to join in your meeting. My name is Eko Hariano. This one is just setting, and I'm sorry if my English is not fluent like presenter before. I'm Eko Hariano from Basics Department, Basic Education Department, at the University of Surabaya. Today I would like to sharing about STEAM education for sustainable development, an effort to innovate basic teaching and learning process in the new era. Okay, next. Next slide. Okay, this is just open our minds about Indonesian demographic bonus until 2045. This is so as about the power of Indonesian people, Indonesians community. So good management of people, because we have a lot of working people. This become blessings if we can give good service to a lot of people. But this one's to become social disasters if we lose to give good service, especially about quality of education. Next. Next. Okay. Before this slide, you can back to previous slide because this is important for us to know. Previous slide. No, next slide. Before this slide. Next, before slide. Before this slide. Previous slide, but okay. This is our challenge, strengths and problems of learning outcomes of primary and secondary education in Indonesia. Actually, if you had you checked the PISA document about score and ranking, especially for Indonesia, sometimes we scary with this fact because we was tried to give good service to our prospective teacher for students, but the PISA scores still low. And then if we try to check all comment in the right side, actually we have situation is bad, consistent as one of the countries with the lowest PISA results ranking. These our stages, these our country stages. This become big responsible for us how to make good situations. We have big homework to create what can you do, what can we do, so our students have good literacy, especially about science literacy. And then PISA scores are stagnant in the last 10 until 15 years. Actually, we have no effort to get good stage to up stage. And then, however, the difference between the scores and the weight OECD scores has increased slightly. Actually, you can check from this picture. We have opposite situation. We try to create good situations, how to answer all challenges, especially related with PISA, because PISA give good information to us to assess about the quality of our education. We must create good innovations, especially for basics teaching and learning. So we must open mind if our physics teaching or learning process is needs more infusing innovation from us, so we can found good model to this physics according to our student situation. And then from the right side, we can know about 21st century skills, society 4.0 for SDGs, and then sustainable development goals. This one is designed for us. What can you do if we have good sign for our situation, for our world? Yeah. So this one is good. How to create good models, good innovations in basics teaching and learning. So on the below, we have one questions: how to develop courses for prospective teachers to increase awareness of ESG based on STEAM education. Actually, we have 2 points in here about STEM and ESG. Sometimes we bore it to teach about physics because physics is basic materials. If you teach physics to your students without innovation, like your students eat a lot of food, but without what I can say, yeah, just common, yeah. They have not good feel to learn about physics. This one is according to our situations. If we try to observe our psychological students about physics, they not interest again. This one is a bad fact for us. We must think about this one and what can we do to get revive, to refine about this situation. And the next, Pak.
Okay.
Okay, next slide. This one is the challenges of 21st century. I think a lot of participants know about VUCA, volatile, uncertain, complex, and ambiguous. This one is new, informed to us. What can we do if we have this information like volatile? The environment demands to react quickly to ongoing changes that are unpredictable and out of your control. Uncertain, the environment requires you to take action without certainty. Complex, the environment is dynamic with many interdependencies, and ambiguous. The environment is unfamiliar outside of your expertise. This is give warning to us. So we must to become what I can say, teachers with creativity to create good model, good innovation for make prepare, but a good prepare for our students. So they will ready to answer all questions according to situation now. Yeah, I often call new era. And then next part. Now I try to show you about modify for basics teacher for preparing the excellent generation. Actually, we have 2 points about STEAM, ESD to become STEAM ESD. This one is new innovations in our world. So we will try to make excellent service to our students, not only understands about basics materials, but our students have space to imply our concept according to surrounding problem, according to daily life problem. Not only think now, but for the future. This one is important point for me. Next. This one is STEM project advantage. Actually, we have 5 points: reflection, research, discovery, applications, and communications. Actually, if you imply STEM, you have time to train about reflection. train students to find the context of the problem to start investigating. This is very important to learn about basics, not only here, all information from teacher, but students have time to do anything. They have time to hands-on activity until minds-on activity to get many more facts until they can find or prove by evidence according to law, according to statement, and so on. And about research, train students to select reading materials or collect information from relevant resources. They not only believe with information, but they must prove by evidence. They collect many information to conclusion according to problems. This one point of research. Sometimes it be just here, all information from teacher. Teacher not give information, not give reasons why the Newton say like that. And then forget the really informations. They have no time. They have no tools. They have not media. Sometimes physics become dry. So this is a gap for our students. If they not interested in basics, I think is common. This one's our responsibility to innovate about this one with combine STEM and EAC. Discovery. Train students to discover the learning process and determine what is still unknown. Good. Sometimes we can provide all information to our students. Discovery is good stage to give time to our students to get informations by themselves. They can learn from many resources. So you just facilitate to your students to looking for, and then you give time your students to present in front of class about the result. This one discovery. If you have time and this give discovery by proportion, I think it's very wonderful to increase your student skills, especially how to communicate based on fact, how to communicate based on literature and so on. And then application, train students in problem solving. Student test, the designed model based on the test results. Students can repeat the previous step. Application. Sometimes our students don't understand why they must learn about basics. Quantum, what for? Kinematics, what for? We not introduce about function, about fruitful from our concept. So this is lost part from us. We must rewind again how to teach in basics according to our student work, according to our student age. We must start from problem. Problem is good starting. Problem is good start. From the problems, our students will think about something, and they will try to concepts. So to get solutions about answer, he will try to learn our communications or try to create experiment to prove by evidence. This one's application. And then communication, develop communication and collaboration skills and the ability to receive and apply constructive feedback. Communication skill is less for all students. Sometimes you can good speak in front of class because just read from your books. This one is your time to give speech, to create, to train your student skill for communication. Give space to us to speak according to what I can say, according to result from your student. This is very important. This one is benefit from a STEM project. And then next. This one is framework for STEM. STEM lessons focus on real world issues and focus on problems. I'm very agree about this one. If we think about STEM. STEM acronym from science, technology, engineering, mathematics. Sometimes we add with A, arts, yeah, to become STEAM, and then sometimes to become STREAM, sometimes to become STEAMY, and then we have many kind of STEM. Basically, STEM. STEM is good. STEM lessons focus on real-world issues and focus on problems. We always start from problems. Is if we will apply, we will integrate STEAM in our basics teaching and learning. And then, beside that, STEM lessons are guided by the engineering design processes, not only science process skills. Our students have time to develop this engineering design processes. They think about engineering according to solutions based on the problems. Not only think about commonly states of scientific process skills, but they have good creativity to create solutions according to the problems. And then STEM lesson apply rigorous math and science content. Please remind, math is tools in science. Math is tools and purpose, not purpose, not objective, not orientation. Math is tools. We must prepare with good math so our students have good skill to calculate anything according to our STEM. Sometimes our students less power of mathematics, so they don't have good creativity to apply mathematics to calculate according to models and so on. This one is not. You must train about mathematics, so they have skills to use mathematics to calculate anything. If, for example, if we try to make a box, they can calculate about length, about height, and so on. This one is mathematics. And then science content. This one is important. So from this framework, we are not teaching all about this one, but we are only facilitator. We facilitate to our students. They will looking for many informations according to them, according to students' want, according to students' required. They will ask about concept to us, to me, to ours. So we can create good independency for our students. Choose them. STEM lessons allow for multiple rights answer, not one answer. We have multiple rights answer. Right is representative, depends on argumentation. This one is good. This is give an influence to students' thing. They're not permanent thing, but they have many options to give information, to give answer according to argumentation. Argumentation skill is very important. STEM lessons immerse students in hands-on inquiry and open-air exploration. STEM gives space to our students to do anything. Don't stop. You must give space, you must give facilitate. What can student do to give solutions according to the problem? And then last, lessons involve students in productive teamwork. They need good partners to join for communication, for discussion, to create a good product according to problems. This is good model for us. So if we can integrate STEM in our basics learning, I think very wonderful, because we will give good experience. We will create good learning experience to students and to become basics interesting for our students. Next. Okay, this is sustainable development. Maybe you ask why or what is sustainable development? Ladies and gentlemen, actually, we are not only live now, we hope live until future. And then we have good situation, not only now, but until future. This one is living. Living for us, not only for me, for all, must be good, not only now, but until future. This is good point to integrate in basics teaching and learning. Students not only think about now, but until next time. We have 6 points about sustainable development. For the first one, living good life, systematic planning, dynamic process, thinking about future generation, living quality, life within the carrying capacity of ecosystem, meeting the needs of current and future generation. This important point in sustainable development. Main topics according to sustainable development is we must think until future, not only now. And the next, development that meets the needs of the present without compromising the ability of future generation to meet our needs. We have big responsibility to bring our now generation to ready face the next situation. This is big responsibility for us how to prepare this one. Sustainable development is together concern for the carrying capacity of natural systems with the social, political, and economic challenges faced by humanity. This is our responsibility also. We have 3 pillars in education for sustainable development. For the first one is economy, and then society, and the environment. Sometimes we are not saying if the basic have good relation with economy, society, and environment. This is new information for us. How to create good basic teaching about the results will give influence to economy, society, and environment. And then from this forum, I just remind you, this one is important for us. And the next, this one is 3 basic pillars of sustainability. Actually, according to my informations before, we have 3 pillars: people, economy, and ecology. Yeah, ecology is economy. Yeah, people like society, church, survival, life expectancy, health, food, security, education, equality, equity, equal opportunity. This one is people. And then about economy, living, waste, wealth, productive sectors, consumption. Yeah. And then society, stabilize populations, housing, institutional capacity, social capital, regions, and so on. This is parts from the SD with 3 pillars: people, economy, and environment. Next. Okay, this is main area of basic perspective and learning outcomes. Yeah, actually, we can modify according to our concepts how to create the good basics teaching learning process with infusing STEM and ASI. Actually, these parts very important to understanding about the content, like social perspectives, this one, human rights, peace and human security, gender equality. This to become content in our learning. And then about environmental perspective also, about climate change, for examples. Yeah, this one is big issues in the world now, and then this one's become important part in our teaching, especially about basics, and then economy perspectives. Next part. this good information for us. Yeah, actually, this is our collaboration. These are collaboration research with 11 countries in Asia Pacific. Actually, we produce Asia Pacific EIT Teacher Competency Framework. Yeah, we have 3 domains. For the first one, facilitated learning. The second one is continue to learn and create. And then the last one is connect, collaborative, and engage. This is have fine orientation, shape features, able to practice ESG here and now towards shaping sustainable features. This is good point. And then we can check from the domain for facilitated learning, able to create and provide learning opportunities for learners to develop their sustainability capacity. We have good message from the framework, from this framework. Actually, we must provide learning opportunities to our students, like materials, curriculum, class situation, and so on. This one is our domain to facilitate learning. So not only think about how to give information, but give space to students' growth with many creativity according to our topics in basics. And then about connect, collaborate, engage, able to promote collaboration and partnership to support the ESG policies and practices within and outside immediate communities, including local and national authorities. Yeah, maybe this one is not our area, but we must know about these domains. And the last one, continue to learn and create, able to reflect, innovate, and transform knowledge continuously as a professional in ESG practices. This one is good point. And then we must open minds about ESG information. So if you want to create good innovations basics, we can combine between STEM and ESG. Next part. This is themes in ESG implementations. Yeah, actually, we can choose one from our topics like water, peace, and human security, poverty reduction, gender equality, and so on. Yeah, depends on your topics in basics. Yeah, actually, we can choose various topic is close with our main topics in basics. Yeah. Next. This one is learning development oriented STEM. Yeah, actually, we start from issues, especially about environmental, social, and economic issues. Yeah, to become a starting point to start learning STEM base, and then we can integrate with many innovation model like learning cycle, 5A, inquiry-based learning, problem-based learning, model learning, other. Yeah, we can choose another. Okay, and then we can apply in middle school, high school, vocational, and higher education. Next.
Excuse me, Professor.
Yep.
You have about 2 minutes to presentation, and we can go to Q&A session. Thank you, Prof.
Okay, thank you, Pak Anas. We can continue to next slide. I just show about my experience to apply STEM and ESG in our teaching in class. Next slide, Pak. Next, yeah, maybe you can do it alone. For you can do it for my slide. This one is STEM. Next. Okay, this is examples about research of learning about basics based on STEM ESG. I often call it an example research of learning for leveling students' creativity through STEM-based learning projects. Actually, we are not only conducting STEM ESG, but we can continue to conduct research in class. Yeah. Next, Pak. Next. Okay, this is many examples about students' products applying STEM EAC in physics teaching and learning. Sensitized solar car, and then next, Pak. Yeah, only 2 minutes. Solar power wooden car. Yeah, this is students produce, yeah, for renewable energy. Next, vertical extreme turbine. Yeah, this is good prototypes for energy, renewable energy. And then simple floods alarm. Yeah, so this very required in Indonesia. Yeah. Alarm floods, simple flood alarm. Next, alarm hujan, rain alarm. Yeah, this one is good also. Next, yeah, this is one from our benefits in integration physics and STEM. Actually, we can observe about students' creativity. This one is our data with my team. And then still waiting publication. Next. Okay, this is Albert Einstein saying physics is essentially intuitive and concrete science, yeah. But mathematics is only means for expressing the laws to govern phenomena. Actually, physics is very important. Physics is everywhere, yeah. Physics is all. Next. Ya, guru yang membuat fisika membosankan adalah kriminal. Thank you, Bapak Ibu. This is my presentation. I'm sorry if my speak is not fluent. I'm Indonesia, yeah. So I hope you can understand about my information and I give to Pak Anas. Okay, thank you, Pak Anas.
Okay, well, thank you very much, Professor Eko, for such a thought-provoking and inspiring presentation. We have many insight from Professor Eko presentation. We now have time for a brief Q&A session, about 15 minutes. If you have questions for our keynote speaker, please feel free to raise your hand or type your question in the chat.
Thank you, Prof. Eko, for the insights and for the informations. And my name is Rahman Eka Cahya, and I would like to ask something according to your presentations before. Prof. Eko, your previous data or previous slides about the PISA scores and rankings for Indonesia students, mostly they are below competencies. But this STEM model in learning, it could possibly increase the students' average competencies. We know this year in senior high school especially, there is a different or new curriculum. It's called deep learning curriculum. And me as a teacher or maybe most teacher, we need to adapt. If we have STEM model before in senior high school and we try to apply it to our students, we need to adapt to this new curriculum. And my question is it possible to apply this STEM model in learning in the new curriculum, especially in physics, in short time? Thank you, sir, for my question. Thank you.
Okay, thank you, Mr. Rahman Eka. Okay, now we can invite Professor Eko to respond to a question from Mr. Rahman Eka. Are you from Rahman Eka Cahaya?
Yes, sir.
What's your from?
Oh, I am from State University of Surabaya.
Student or
Yes.
lecturer? I'm sorry.
I am both student and I am now as a teacher of senior
Master
high
or
school.
doctoral?
Yeah.
Doctoral
Yes.
program.
Master student. Yeah, master
Oh,
student. Yes.
thank you. Please, Mr. Eko, to respond.
Okay, thank you, Pak Anas. Terima kasih. Thank you, Pak Eka. Yeah, you have good question for me about it's possible to apply STEM and ESD in basics related with the new curriculum. Yeah, especially deep learning curriculum. Yeah. According to our observations about the deep learning curriculum, STEM is priority. STEM is very possible to imply in new curriculum. If you check about the orientations of new curriculum, it required students have good understandings about concepts. Not only this one, but students have skills to make solutions for life problems. So in the deep learning curriculum, requires students have young, what I can say, skills. Yeah, students have good skills to give, to conduct basics teaching and learning process. Yeah, and then they not only hear about information from teacher, and then they still have time to apply basic concepts to give solutions according to the basic problems related with the lives. For example, if we teach about force, force is as what I can say, topic is constant topics, just involve about force, about mass, and about acceleration, for examples. But through STEM, we can bring a new situation to our students. How to create new tools according to the situation based on this concept. So your students will deep learn about dynamic concepts, not only remind about formulations, but they have space to imply according to problems. Yeah, and then you must give time to present. Yeah, to up your student skills to presentation, to skill for communications and so on. Yeah, I think this one is very possible, Pak Eka, because for new era, we not only give informations because our knowledge is limited. Yeah, I think if your students have more information about dynamic concepts. Yeah, sometimes we just what I can say, not aware with our students. Yeah, this one just your ego. Yeah, this one's starting point for us to give a lot of to give a big area for our students to promote anything, to speak anything according to our program. Yeah, this is my answer, Pak Eka. Yeah, very possible to apply in the new curriculum. Yeah, thank you, Pak Eka. I'm sorry if my presentation is not clear. Okay, I'm sorry. Thank you.
Thank you, Prof. Eko, for the answer.
Okay, thank you so much.
Thank you for excellent question, and thank you, Prof. Eko, for the thoughtful responses. Okay, everyone. Unfortunately, we are running out of time, so we will need to wrap up the Q&A session here. Okay. Mr. Professor Eko, if you maybe have closing statement in this session.
Yeah. Okay. Thank you, Pak Anas. Yeah, I just remind we are have big responsibility to bring our new generations to succeed, to face many challenges, not only now but future challenges. So we must create good innovations in our physics teaching and learning with many many informations like ESG, STEAM, and so on. I think this to become a good service for our students. So they will interest again with physics. This one is my closing statement. Okay, thank you, Pak Anas. I'm sorry. Yeah.
Okay, thank you. On behalf of the organizing committee, we certainly thank you for Professor Dr. Eko Hariano for sharing his invaluable insight today. Your contribution to really enrich our understanding of how science education can shape a more sustainable and resilient world. Okay, let us give another round of virtual applause to our keynote speaker. Okay. Okay, thank you for all for your participation. We will now proceed to next session and return to Mr. of Ceremony. Okay, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Professor Eko and Dr. Anas, for the enriching presentation and discussion. At this moment, we would like to invite Dr. Muhammad Anas Thohir to officially present the certificate to Professor Dr. Eko Hariano. Dr. Muhammad Anas, the stage is yours.
Ya, Pak Anas. Okay, thank you, thank you.
Okay, thank you.
Now we proceed to the fourth keynote speaker, Dr. Michael Walter from the University of Freiburg, Germany. This session will be moderated by Dr. Renat Wafa Maftuhin. Dr. Michael and Dr. Wafa, the time is yours.
Okay, good morning, everyone. Welcome our speaker, our college, and all our participants. So it's great pleasure to welcome you to the second international seminar on physics and its application, ISoPA 2025. So as your moderator for this session, I'm truly honored to introduce what I believe will be a very insightful and inspiring talk. So today, we have a special opportunity to hear from visionary leader. It is with great enthusiasm that I introduce our distinguished keynote speaker, PD Dr. Michael Water. Professor, welcome to State University of Surabaya. Can you hear me, Professor?
Yes, yes.
Okay,
Thanks a lot for the invitation.
Okay.
Yeah.
Yes. So Dr. Walter is more just a leading figure. He's also driving force in the computational modeling and material science. So as working group leader for computational modeling at the University of Freiburg, Germany, his leadership helped shape a very method that tools used in this field, so including atomic simulation environment or ICE, and then GPO, and his habilitation in physics in 2011 demonstrated his deep knowledge, forming the basis of highly successful career. So what truly makes Dr. Walter stand out is his pioneering work where chemistry, physics, biology, and computer science meet. So he's leader in using computer models of electronic structure and also advanced spectroscopy to understand the functional materials and complex systems. Beyond his impressive research, Dr. Walter is also committed educator, so he created innovative scientific programming course at the University of Freiburg using the flipped classroom approach. So with an amazing H index of 39 and nearly 14,000 citations, his ideas are recognized and highly influential worldwide. So today, Dr. Walter will share his valuable insight on electron, the glue of matter, insight from theory. So we expect a talk that will not only inform but also inspire us, encouraging us to think differently about the future of science and its impact on society. So please join me in giving a very warm welcome to Dr. Michael Walter. So the stage is yours.
So thanks a lot, Wafa, for this kind introduction. I try to share my screen. So I hope you see this, and I start with the presentation. So can you see the presentation?
Yes.
Okay, so super. Thanks a lot for inviting me to this nice event, and I'm really honored to be able to give this talk here, which introduces a little bit of our methods and what we do, and I give two examples of this. So I named it that electrons, the glue of matter, and insights from theory because we are doing theory. So the agenda of my talk is, at the first point, I explain what is the methods that we use. So what are we doing, or what are we basing our theory on? And this is density functional theory. And then I will present two applications. The first is mechanochemistry, where Wafa was very active in my research group, and then the second is some internals about batteries, which are important, of course, for the sustainable future, where we have to base our energy consumption on electricity, and we can store it in batteries. All right, so let's dive into the first part, and this is about the methods. And so on the right-hand side, I show this cluster. This cluster here, so this is a metal cluster basically with some ligands around. So we have a lot of atoms there which are connected, and we want to study the properties of such a beast here. And so what should we do in order to describe this theoretically? So in principle, it's very simple. We have this, the constituents of matter are the nuclei that we see here and the electrons which are around and which are connecting these, so the glue of matter, as I said. And the nuclei have some, we know the nuclear charge, this is Z, so Z times the unit charge. And we know the electron charge, which is just the negative of the unit charge. And their interaction is just by Coulomb forces. So in principle, the interaction is very simple. And in principle, also every physics student should be able to write down the quantum mechanical equation, which is the Schrödinger equation, which we see below here. And you can write it down easily. You have the sum over all the particles here. You have the kinetic term, and which involves the mass of the particles, and then they interact via Coulomb. So you have the two charges, Qi, Qj, and then it's inverse proportional to the distance. And this looks very simple, but in order to solve this equation, this is not so easy because we have all these coordinates which come into play. So we have some help from nature, basically, that we have different energy scales for the nuclei and the electrons. This is shown here for the absorption spectrum of such a cluster here, where energy range from 0 to 1 electron volt, basically. And where we see some peaks at the low energy range, which are related to the nuclei. So basically these are vibrational spectra that we see. So this is the absorbance, what is plotted here. So here, this is a vibration that is responsible to having these peaks. And then we have at higher energies, we have the electronic absorption. So these are is the electronic system which absorbs. And we see that these ranges are separated. And this helps us because we can say, yeah, for these higher energy absorptions, we need to describe the electrons. And for the lower energy absorptions, we need to describe the nuclei. And we can separate this. And this separation comes basically through the Born-Oppenheimer approximation. There one pictorially says one treats the nuclei classically, and the electrons we have to treat quantum mechanically, but they are in the field then of these fixed nuclei at each time point, basically. So we separate our wave function, which depends on the nuclear coordinates, this capital R, and the electron coordinates, such that we have a nuclear wave function, it's chi r, which is a vibrational wave function, basically. And then we have this psi, which depends on the electron coordinates, quantum mechanically, and then the nuclei are treated as fixed here. And then we only have to solve the equation for the electrons. And only means that also this is quite complex. And to see the complexity of this, I stole this from the Nobel lecture of Walter Kohn. So we have to see for such a cluster, like I show here, we have about 750 atoms and we have about 3,500 valence electrons. So in order to describe this theoretically, if we just say we take 3 points through this to describe every coordinate of the electrons, just by 3 points in every direction, then which is not much, then we have 3 to the 3 numbers to describe this direction or this position for each electron. So we have the complexity of our electronic wave function is 3 to the 3 to the power of the number of valence electrons, which is about this 3,500. And this is a number which is 10 to nearly 5,000. And here I usually ask the question, what to think about the size of these numbers. What is the number of atoms in the known universe? But through this environment that we have, I answered this myself. So the current thinking of the number of atoms in the known universe is 10 to 81. So it's much, much smaller than this 10 to nearly 5,000. So even if we would be able to store one number at each atom, we would never get the complexity of the full wave function. So we have to do something more in order to describe this problem. And there's something more. We know this is one of the setup is the Hartree-Fock approximation, where one says this wave function of the electrons is just a singles later determinant with single particle wave functions. And these wave functions are, we have n wave functions for n electrons in the system. So 3,500 wave functions we have basically for our cluster here. And then we make a Slater determinant out of this, and we end up with a single particle equation where we solve then for these single particle states basically. And these single particle states, they live in an effective potential, which is built from all the other electrons that are there. This is an approximation, but Hohenberg and Kohn showed that one can do something similar. So basically, they showed that there is a one-to-one correspondence between the external potential V, so which is given by the nuclei for the electrons, and the electron density. So if we know the electron density of the electronic ground state, then we also know what is the potential that the electrons live in. And then Hohenberg and Kohn also showed that because of this one-to-one correspondence, one can describe the ground state energy as a function of this electron density. And one thing what one does here is one writes this functional in some form where we know a lot of terms. And this is, one writes it as a functional of, so the kinetic energy, T of n, as a function of this electron density. Then we have the interaction between the potential and the electrons, which we also can write down. And then we have the self-repulsion of this electron density, because this is a charge density, and this self-repulsion or self-interaction is Coulombic, as we have the Coulomb forces there. And then there comes an additional term, which is called the exchange correlation energy. And this is, in principle, it's unknown, but this is approximated in density functional theory. And we have some rather good approximations for this. So we can then calculate the ground state energy of the system in this way. And Kohn and Schramm then came with an extension. So they said one can also describe this electron density, so the real electron density, by a similar thing like in Hartree-Fock, by a sum of all these single particle wave functions. Basically, there should be a square here. And these can be calculated, the single particles, in a very similar equation like in Hartree-Fock, where one also has some effective potential, basically, where these single particle orbitals live in. And this effective potential can be written down. So this contains a potential from the nuclei, from the electron repulsion, the classical one, and then we have a term which depends on this exchange correlation energy, which we approximate. And this is the equation that we use, and we can use this then to calculate things. And this is what I want to bring you or show you some applications of this theory. The first application is mechanochemistry, and here I have an example of where this could be useful. And this is on the right-hand side, we see some specimens. So these are basically plastic stripes here, which are pulled. And into these polymers that's of this plastic, our collaborators have introduced these molecules, which are spiropiran molecules. So the spiropiran is a nice molecule which is invisible in its closed state. So this what we see here. So you cannot see it basically. But if you apply force to the end of the polymer, so the polymers are connected here, then this carbon-oxygen bond breaks. Here the oxygen goes away from the carbon, and this molecule gets in its methionine form, and it's colored then. So this is what you see here. If you have the unstrained plastic thing here, and then you pull on it, then the color changes to be blue. So these bonds, they open, and then one sees the color. And the idea is to see the force distribution inside of the polymer, which is otherwise very hard to get. But here we have then a means to see where the forces apply inside of the polymer. And we see then if the specimen breaks, then the color goes away with time. Okay, and we thought about how to describe these things, and here is what I show here is an example of 4 different spiropiran versions. Basically, they have different side groups, and then they have a little bit different properties. And then one sees if one pulls them, so if one applies strain, this is on the x-axis, the pulling is increased here, then one sees there is absorption change, so which means this is the color change that we see. And what we see is that for this P4, this has the strongest color change. Then we have P2, which is the next, and then this P3 and P1, they have much less color change with the same strain that is applied to this specimen. And we thought about how to describe this thing and what are the barriers and so on for this opening of this bond. And bond opening is a thermally activated process. So this means we need temperature to allow us to break this bond. And because of that, it's a stochastic process. So we can only give most probable force where this bond opens. And because it's stochastic, it also depends on the loading rate, which is the rate of force increase that we apply here. So if we pull faster, then we see a higher force than if we pull slower here. And for the loading rates that are reasonable for such pulling that we have in the experiments, we are about in this range of the loading rates, and then we see we have here the ordering of these different versions of the spiral pyramid have different forces, different most probable forces where they open. And they are in the range of 0.1 to 0.4 nanonewton. And we see the ordering is like what we see in experiment. So we have the lowest force is for this lilac one, then the next force is for the orange one, the next lower force, and then these two, the green one and the blue one, they have about the same force where they open, and this gives also the same response. But these were for bond breaking basically, and we also have developed with our colleagues some other principle, and this is continuous force response molecules, or ART continuous force molecules. And these have the idea behind of this is that one has some donor and acceptor parts in these molecules, and depending on the angle between this donor and acceptor parts, we get different colors basically. And then we can see if we pull then on the donor and acceptor and we change the angle, then the color change. So the absorbance wavelengths change, or what they measure here is the emission wavelengths, which changes. And here Wafa was in my group and was calculating what is the emission wavelengths basically that we expect depending on the force. So with his calculations we could predict, depending on the force which is applied to the molecules here, what kind of color do the molecules have if they emit light. And this made it possible to relate the experimentally measured wavelengths to the forces that are in the material. And this was then also, we applied it to some more complicated molecules where our collaborators also managed to create such handles in these molecules. So here the donor part is this central part and the acceptor are the side groups. And these handles basically, they allow to rotate our acceptor group relative to the donor group. And then Wafa found out that for these handles here, they can be in different configurations. And depending on the force that is applied, we have different distributions of these handle orientations. And this gives us a very sensitive measure for very low forces, because already at low forces, this UU configuration here with the handle in this direction flips to the other direction, and this gives then also a slight color change between these two. And so we are very sensitive with these molecules to small forces. And what I have to say that these forces which are on molecular level can only be predicted by theory, because the experiment cannot look into this at this level of the molecules like what we can do. And here Wafa was very successful, and we have very nice papers about this. With this, I come already to the second part of the applications that I want to show, and these are lithium-sulfur batteries. And the idea of lithium-sulfur batteries is to use sulfur instead of cobalt in the lithium-ion batteries that we have. You know that lithium-ion batteries are now everywhere in the cell phones and in the cars and so on. And the idea why one wants to use sulfur is that sulfur is really abundant. Like one sees here, this is the harbor. I guess this is the harbor of Vancouver or something, where there are really mountains of sulfur lying around, which are waste basically from oil production. And so sulfur is there, is highly abundant, it's cheap, and what it can replace cobalt, which has many problems in the cathode of the battery, so at the plus side of the battery. So one can use their sulfur, and sulfur goes together with lithium plus, so with the lithium ions, and gets negatively charged. So the lithium ions like to be there, and this was shown that it works, this battery, but it has severe problems because there is this so-called shuttle effect, and this means that these lithium sulfur compounds here, these molecules, they tend to go to the wrong place, and then they destroy the molecules. And in order to, not the molecules, they destroy the battery. And in order to fix these sulfur chains to the place where we want to have them, our collaborators managed to use inverse vulcanization. So this means to fix basically the sulfur chains in polymers. So they create polymers where we have sulfur chains connected to organic molecules. And then in this way, one hopes that the sulfur chains are fixed and there, and the lithium ions come to the sulfur chains, interact with the sulfur chains, and they stay there. But the question is, the experimentalists, the chemists that we work together, they create this material, but then they want to know what kind of sulfur chains are. So what lengths of sulfur chains are created by this inverse vulcanization. And then one has to get some means to look into the material and possibly also look into the material in batteries when they are working, so in operando. And this is possible by X-ray absorption, which is measured by some other colleagues of us in Berlin, where they have a synchrotron, and this synchrotron basically this is a source of very high number of X-rays. And X-ray absorption is a process where the atoms, basically here the sulfur atoms, they absorb some X-rays, and then the electrons from some core level in the atom gets promoted to some valence state in the molecule. And this is very element specific. So one can see specifically the sulfur atoms because one gets out some electron from the sulfur 1s state, and then one can see in which environment basically these sulfur atoms are and what are the spectra for this. And in order to understand the spectra, we did calculations in order to see how would the spectra look like. And a very related experiment to X-ray absorption is X-ray photoelectron spectroscopy, where the electron is not promoted to some bound state with some valence orbital, but it's set free, so it flies away. Then we have the photoelectron. And we already looked into the possibility to calculate X-ray photoelectron spectroscopy, and this is displayed here for different elements that we have carbon, nitrogen, and also sulfur here. And what is plotted here is we have the photoelectron spectral energies on the x-axis that are measured in the experiment, and on the y-axis the calculated ones for different molecules. And one has a very nice correlation between the measured photoelectron spectra and the calculated photoelectron energies. And like this, we can then identify what kind of molecule we have. And the same happens also for sulfur. So this is the sulfur 1s photoelectron energies, but also X-ray absorption energies that we have added here. And one sees also this nice correlation there, but there is just one thing that we observed, and this is there is a little bit of a shift between the experimental values and the calculated values, but we can use these measured values and calculated values here to determine this shift. And we see that the shift is always the same and it's just depending on the core hole state and the exchange correlation energy that we approximate. And so we use this shift to correct then the X-ray absorption spectra, and we can predict then the X-ray absorption spectra very nicely. We see here these are experimental X-ray absorption spectra, and the thick lines, and our calculations are the thin lines. So we can nicely predict the spectra and then also assign basically from the spectra what we see. Here we have one sulfur gives this one peak, and two sulfurs gives two peak, and three sulfurs gives this more broad distribution. And like this, we can then apply this for the real. We can also look for more sulfurs that we have, and we can find out what is the correlation here. And with this, we can then look into this material that we are interested in. And for instance, here we have some material which has a low content of sulfur and a lot of polymer. And we see that we have a spectrum which looks very much like the just one sulfur. Then we have more material, so more sulfur in, less of the polymer, and then we see that we get longer chains and so on. So we can help to understand how this material looks like. And with this, I'm already at the end, and so I hope I could show you that DFT is efficient, and in principle it's an exact method to calculate the electronic structure. We have seen that the simulation can reveal the force response for bond breaking and also for deformations, and that X-ray spectra are element-specific probes that can be predicted on absolute energy scale. And with this, we could basically look at the sulfur strand lengths in this polymer material for lithium sulfur batteries. And with this, I thank you for listening. I thank my group, and especially Wafa, for inviting me to this nice event. And I'm open for questions.
Thank you, Professor, for the truly insightful and also inspiring talk. Your exploration into electron, the glue matter inside from theory, particularly through the mechanical chemistry and also advanced lithium-ion battery. So now we will open the floor for a brief question and answer session. If you have a question for Dr. Walter, please approach the microphone or raise your hand, or you can also send to the chat box. So there are two questions here from the chat box. So first, I would like to read the question. So thank you for fascinating presentation, Dr. Walter. I would like to ask, what are the main limitations of the DFT when applied the strongly correlated system or when studying the excited state? So this is the first question. Professor?
Yeah. Yeah, of course. DFT is not exact. Yeah, as I said, we have to approximate this exchange correlation term, and we have so everything is with a grain of salt, and also these transitions that we calculate, for instance, for the bond break, these things are quite complicated, so to say, through this, that the time scales are rather large for this, so we cannot do some ab initio calculations with ab initio MD or something, but we have to use transition state theory to determine these barriers that we have. But the good thing is that despite that the calculations of the optical spectra are not 100%, the shifts are not that bad. So this is really what Waffa did. So he did optical calculations with time-dependent DFT, and then he looked then on the dependence on with forces for the shifts in these optical spectra, and everything looks quite fine. So what is amazing is that we have calculated the force response of the bond breaking and the force response of these more deformations there. And quite recently, the experimentalists have checked this, that they have put both force measures basically into the same polymer and pulled on that, and our predictions agree. So I was really very happy to see that our predictions seem to be really correct, despite of these problems that we have. I hope this answered this question, and I see another one.
Yes. So another one question from Anna, so physics student. In the study of polymer that can respond to force to color change, how is the DFT able to predict the quantitative relationship between the magnitude of the mechanical force and optical transition at the molecular level? Are there any limitations to scale of the system that can be accurately modeled by DFT in this context?
Yes, so clearly we have a lot of restrictions. So what we can model basically is the size of molecules of, let's say, 100 atoms, or in the range of hundreds of atoms. But then it's this is the maximal size. Now the people are going more and more, they learn to machine learning models to describe larger things. But on the other hand, the thing is that it's not only size that you have, because we always simplify things in physics, and so we can overcome limitations. For instance, as I said, by from the time scale that we can model and the size by using transition state theory, and then we understand much larger time scales than what we can model ever on a computer. And our understanding lives very much, in my view, from these simplifications, because we need to create rather simple models in order to understand something, and that's what we do. We simplify the world in order to understand it. And I hope this answered this thing. And I see another question about the dual particle wave nature of the electrons. Yes, that's true. Basically, in my head, as I imagine electrons, it's more like a wave. So I do not
use in my imagination the particle nature of the electrons, but more it's a distribution that we have, and that's what we solve basically. We solve the Schrödinger equation in DFT, and we cannot get around of this for the electrons. For the nuclei, we treat them classically mostly, but if you want to look into the details of these emission or absorption spectra, then you also see you need quantum mechanical treatment of the vibrations, which gives also these peaks that I have shown in my talk. And these you also do not get without quantum mechanics. So I hope this answered that question.
Is there any other question? If not, we give a applause to Professor Walter. So we are thanks for your invaluable contribution to this talk, Professor. Thank you again, Professor.
Okay, thank you again for inviting me to this nice event. It was really an honor to be able to talk here. So, bye-bye.
Yeah. Wait, is there any event from the MC? Maybe we have some token appreciation for the certificate or something?
Thank you, Dr. Michael and Dr. Wafa, for sharing your expertise and insight with us. At this moment, we would like to invite Dr. Wafa to officially present the certificate to Associate Dr. Michael Walter. Dr. Wafa, the stage is yours.
Contribution for this talk, and I thank you very much for your contribution, and yeah, thank you so much for the talk.
Yeah, the thanks is from my side.
We are now heading to the parallel session. Please follow the instruction from the committee. Join the respective breakout rooms. After that, we will conclude today's seminar.
On behalf of the ISoPA 2025 Organizing Committee, we sincerely thank you for your active participation. We hope this event has brought valuable knowledge, collaboration, and inspiration to all of us. I am Ahmad Mida Erumam.
And I am Abila Maulina.
Signing off.
Good afternoon and wassalamualaikum warahmatullahi wabarakatuh.
Welcome to Physics Department, the Faculty of Mathematics and Natural Sciences, Universitas Negeri Surabaya. The Physics Department is located at Building C2 and C3, Campus Unesa, Ketintang, Surabaya. There are two study programs for undergraduate students in our Physics Department, the Undergraduate Program of Physics and the Undergraduate Program of Physics Education. This is the profile of the undergraduate program of physics.
Hello, I am Unesa, the chief of the undergraduate program of physics. Our study program was established in 1999. Back then, our institution was recognized as an institution for the educational program, specializing in producing teacher reform to be a university. This reformation led to the establishment of the non-educational study program, which include the undergraduate program of physics. The undergraduate program of physics aims to strengthen physics educational that has already been established for years. In line with the needs of society and professional work field, this study program also experience dynamic development. The study program from 3 area expertise: material physics, earth physics, and instrumentation physics. Material physics focusing on advanced material research and development of functional nanomaterial based on natural material. Earth physics focusing on intelligence and development of software for mitigating disaster, tsunami, and volcanoes, and early warning system. Instrumentation and optical physics focusing on developing intelligent system based on instrumentation, microcontroller, optical sensor, and optoelectronic. Of course, by designing a curriculum and research group based on these 3 clusters, we want to prepare our graduates excellently, so they can have a professional job in field relevant to their skill and continue their further study. In this purpose, we also facilitate our students with such a program that will polish their professional skill, such as student exchange with university abroad, cooperation with industry, government and private institutions, cooperation in research and publication of lecture and student. Currently, our study program has been accredited A by the national.
Laboratories in the physics study program serve learning and research activities. Students must have got the theory for learning activities, while the actual practice can be done in laboratories such as basic physics, basic electronics, and experiments laboratories. To develop science, students and their supervisor can conduct research activities in physics research laboratories, such as the Earth Physics Laboratory, Instrumentation and Optics, Material and Characterization. Inshallah, the infrastructure to support these activities will be fulfilled in using the laboratory for both research and learning. All users must comply with SOP's standard operational procedure, such as filling out a list of equipment borrowings to the laboratory assistant and checking the condition of the equipment before use.
The Basic Physics Laboratory is one of the laboratories in the physics department that serves students from all departments in the Faculty of Mathematics and Natural Sciences. One of this topic is Newton's second law. In this practicum, students are required to use pulley system to investigate the acceleration of a moving object. Students need to analyze the coefficient of static and dynamic friction between 2 surfaces in the system. All the activities in this laboratory have a purpose to prove fundamental theories in physics with simple apparatus. Basic Electronic Laboratory is one of the laboratories in the Department of Physics, which has a purpose to introduce our students to electronics apparatus and circuits. One of the tools often used in practice is the analog oscilloscope and arbitrary function generator that known as AFG. Students must calibrate both the oscilloscope and the AFG before they use in practicum. The amplitude of the calibration signal must match that indicated on the calibration oscilloscope. Mechanics laboratory is sub-laboratory of experiment, different to basic physics laboratory. In this laboratory, students use more advanced tools in their experiment, which is based on sensor and computer. For example, students use air-track photogate timing system for investigating the force acting on an object based on Newton's second law. data retrieval is carried out on continuous glider mass value to get the object's speed when it passes through the two photogates. The length between the two photogates obtains the acceleration of glider. The average acceleration could be obtained from the data collected on the computer. Another sub-laboratory of experiment is electromagnetic laboratory. In this laboratory, students can do experiments related to electromagnetism, such as charge-discharge capacitors. In this experiment, students investigate the capacitancy of the charge-discharge capacitor based on the graph of the relationship between voltage and current for various components. From electromagnetic laboratory, we move to optical and wave laboratory. In this laboratory, students can do experiments related to optical and wave theories, such as sonometer. These experiments aims to determine the tension, string length, linear density of the strings. The driver and detector coil can be placed anywhere along the string. With a dual-trace oscilloscope, students can examine resonance frequency on the string vibrations. Moving to the modern physics laboratory. In this laboratory, students can do experiments related to the photoelectric effect. The metal plate in the photodiode is illuminated with various frequencies of light, selected from a mercury lamp using filters. The voltage is then adjusted to stop the photoelectric current. The stopping voltage is plotted versus the frequency, and Planck constanta is determined from the slope of the graph. Next is thermodynamics laboratory. This laboratory focuses on experiments related to the laws of thermodynamics, such as the cycle of the heat engine. In this experiment, students determine the efficiency of a heat engine. A heat engine consists of air in the cylinder that expands when the attached can immerse in hot water. The expanding air pushes the piston and acts by lifting the load. The result of this experiment is a graph of the relationship between pressure and volume observed on a computer screen. Another tool is cyclic voltammetry in the laboratory of characterization. The 3000 Cambridge features pulse voltammetry measurements. In this laboratory of characterization, students use universal dummy cell for calibrating the Grammy instrument before conducting cyclic voltammetry tests. The result is a voltammograph graph which shows the relationship between voltage and current. The material laboratory is part of research laboratory in physics department. Students may conduct research to finish their thesis project in this laboratory. One of the tools used in this laboratory is the electrospanning tool, NACRIP 601. This tool has a high voltage power supply, string pump and string drum collector, camera and LCD monitor, silica gel, humidity and temperature sensors. The electrospanning process result can be used in the medical field and as a filters. The instrumentation laboratory is part of research laboratory physics department. In this laboratory, students may create instrumentation components and design apparatus based on microcontroller system. For example, this tool is a 3D printer. There are 4 steps involved in using 3D printer: design preparation, setting 3D printing applications, setting the density and speed of 3D printer, and printing objects. The 3D printer engine will automatically perform the calibration, heating the nozzle, and bed according to what is preset on the computer. Physics laboratory is part of research laboratories in physics department. Areas of research in the disciplines include understanding of geological hazards, such as tsunami dynamics, earthquake, and volcanic eruptions. Research in this laboratory use secondary data collected from reliable sources such as
meteorological, climatological, and geophysical agencies, both Indonesian and overseas. The laboratory is equipped with learning aids suitable for science and physics education students, as well as postgraduate students who want to do research in the discipline for their final projects. The activities in this laboratory involve intense discussion between lecturer and students that interested in investigating into some salient points of how crustal rocks deep down inside the earth move, relative one layer to another, releasing a huge amount of seismic energy through a mechanism called earthquake.
Welcome to Physics Department, the Faculty of Mathematics and Natural Sciences, Universitas Negeri Surabaya. The Physics Department is located at Building C2 and C3, Campus Unesa, Ketintang, Surabaya. There are two study programs for undergraduate students in our Physics Department, the Undergraduate Program of Physics and the Undergraduate Program of Physics Education. This is the profile of the undergraduate program of physics.
Hello, I am Unesa, the chief of the undergraduate program of physics. Our study program was established in 1999. Back then, our institution was recognized as an institution for the educational program, specializing in producing teacher reform to be a university. This reformation led to the establishment of the non-educational study program, which include the undergraduate program of physics. The undergraduate program of physics aims to strengthen physics educational that has already been established for years. In line by the needs of society and professional work field, this study program also experience dynamic development. This study program from 3 area expertise: material physics, earth physics, and instrumentation physics. Material physics focusing on advanced material research and development of functional nanomaterial based on natural material. Earth physics focusing on intelligence and development of software for mitigating earth disaster, tsunami and volcanoes, and early warning system. Instrumentation and optical physics focusing on developing intelligent system based on instrumentation, microcontroller, optical sensor, and optoelectronic. Of course, by designing a curriculum and research group based on these 3 clusters, we want to prepare our graduates excellently, so they can have a professional job in field relevant to their skill and continue their further study. In this purpose, we also facilitate our students with such a program that will polish their professional skill, such as student exchange with university abroad, cooperation with industry, government and private institutions, cooperation in research and publication of lecture and student. Currently, our study program has been accredited A by the national.
Laboratories in the physics study program serve learning and research activities. Students must have got the theory for learning activities, while the actual practice can be done in laboratories such as basic physics, basic electronics, and experiments laboratories. To develop science, students and their supervisor can conduct research activities in physics research laboratories, such as the Earth Physics Laboratory, Instrumentation and Optic, Material and Characterization. Inshallah, the infrastructure to support these activities will be fulfilled in using the laboratory for both research and learning. All users must comply with SOP's standard operational procedure, such as filling out a list of equipment borrowings to the laboratory assistant and checking the condition of the equipment before use.
The Basic Physics Laboratory is one of the laboratories in the physics department that serves students from all departments in the Faculty of Mathematics and Natural Sciences. One of these topics is Newton's second law. In this practicum, students are required to use pulley system to investigate the acceleration of a moving object. Students need to analyze the coefficient of static and dynamic friction between 2 surfaces in the system. All the activities in this laboratory have a purpose to prove fundamental theories in physics with simple apparatus. Basic Electronic Laboratory is one of the laboratories in the Department of Physics, which has a purpose to introduce our students to electronics apparatus and circuits. One of the tools often used in practice is the analog oscilloscope and arbitrary function generator that known as AFG. Students must calibrate both the oscilloscope and the AFG before they use in practicum. The amplitude of the calibration signal must match that indicated on the calibration oscilloscope. Mechanics laboratory is sub-laboratory of experiment, different to basic physics laboratory. In this laboratory, students use more advanced tools in their experiment, which is based on sensor and computer. For example, students use air-track photogate timing system for investigating the force acting on an object based on Newton's second law. Data retrieval is carried out on continuous glider mass value to get the object's speed when it passes through the 2 photogates. The length between the 2 photogates obtains the acceleration of glider. The average acceleration could be obtained from the data collected on the computer. Another sub-laboratory of experiment is electromagnetic laboratory. In this laboratory, students can do experiments related to electromagnetism, such as charge-discharge capacitors. In this experiment, students investigate the capacitancy of the charge-discharge capacitor based on the graph of the relationship between voltage and current for various components. From electromagnetic laboratory, we move to optical and wave laboratory. In this laboratory, students can do experiments related to optical and wave theories, such as sonometer. These experiments aims to determine the tension, string length, linear density of the strings. The driver and detector coil can be placed anywhere along the string. With a dual-trace oscilloscope, students can examine resonancy frequency on the string vibrations. Moving to the modern physics laboratory. In this laboratory, students can do experiments related to the photoelectric effect. The metal plate in the photodiode is illuminated with various frequencies of light, selected from a mercury lamp using filters. The voltage is then adjusted to stop the photoelectric current. The stopping voltage is plotted versus the frequency, and Planck constanta is determined from the slope of the graph. Next is thermodynamics laboratory. This laboratory focuses on experiments related to the laws of thermodynamics, such as the cycle of the heat engine. In this experiment, students determine the efficiency of a heat engine. A heat engine consists of air in the cylinder that expands when the attached can immerse in hot water. The expanding air pushes the piston and acts by lifting the load. The result of this experiment is a graph of the relationship between pressure and volume observed on a computer screen. Another tool is cyclic voltammetry in the laboratory of characterization. The 3000 Cambridge features pulse voltammetry measurements. In this laboratory of characterization, students use universal dummy cell for calibrating the Grammy instrument before conducting cyclic voltammetry tests. The result is a voltammograph graph which shows the relationship between voltage and current. The material laboratory is part of research laboratory in physics department. Students may conduct research to finish their thesis project in this laboratory. One of the tools used in this laboratory is the electrospanning tool, NACRIP 601. This tool has a high voltage power supply, string pump and string drum collector, camera and LCD monitor, silica gel, humidity, and temperature sensors. The electrospanning process result can be used in the medical field and as a filters. The instrumentation laboratory is part of research laboratory physics department. In this laboratory, students may create instrumentation components and design apparatus based on microcontroller system. For example, this tool is a 3D printer. There are 4 steps involved in using 3D printer: design preparation, setting 3D printing applications, setting the density and speed of 3D printer, and printing objects. The 3D printer engine will automatically perform the calibration, heating the nozzle, and bed according to what is preset on the computer. Physics laboratory is part of research laboratories in physics department. Areas of research in the disciplines include understanding of geological hazards, such as tsunami dynamics, earthquake, and volcanic eruptions. Research in this laboratory use secondary data collected from reliable sources such as meteorological, climatological, and geophysical agencies, both Indonesian and overseas. The laboratory is equipped with learning aids suitable for science and physics education students, as well as postgraduate students who want to do research in the discipline for their final projects. The activities in this laboratory involve intense discussion between lecturer and students that interested in investigating into some salient points of how crustal rocks deep down inside the earth move, relative one layer to another, releasing a huge amount of seismic energy through a mechanism called earthquake.
Welcome to Physics Department, the Faculty of Mathematics and Natural Sciences, Universitas Negeri Surabaya. The Physics Department is located at Building C2 and C3, Campus Unesa, Ketintang, Surabaya. There are two study programs for undergraduate students in our Physics Department, the Undergraduate Program of Physics and the Undergraduate Program of Physics Education. This is the profile of the undergraduate program of physics.
Hello, I am Unesa, the chief of the undergraduate program of physics. Our study program was established in 1999. Back then, our institution was recognized as an institution for the educational program, specializing in producing teacher reform to be a university. This reformation led to the establishment of the non-educational study program, which include the undergraduate program of physics. The undergraduate program of physics aims to strengthen physics educational that has already been established for years. In line with the needs of society and professional work field, this study program also experience dynamic development. This study program from three area expertise: material physics, earth physics, and instrumentation physics. Material physics focusing on advanced material research and development of functional nanomaterial based on natural material. Earth physics focusing on intelligence and development of software for mitigating earth disaster, tsunami and volcanoes, and early warning system. Instrumentation and optical physics focusing on developing intelligent system based on instrumentation, microcontroller, optical sensor, and optoelectronic. Of course, by designing a curriculum and research group based on these three clusters, we want to prepare our graduates excellently, so they can have a professional job in field relevant to their skill and continue their further study. In this purpose, we also facilitate our students with such a program which will polish their professional skill, such as student exchange with university abroad, cooperation with industry, government and private institutions, cooperation in research and publication of lecture and student. Currently, our study program has been accredited A by the national.
Laboratories in the physics study program serve learning and research activities. Students must have got the theory for learning activities, while the actual practice can be done in laboratories such as basic physics, basic electronics, and experiments laboratories. To develop science, students and their supervisor can conduct research activities in physics research laboratories, such as the Earth Physics Laboratory, Instrumentation and Optics, Material and Characterization. Inshallah, the infrastructure to support these activities will be fulfilled in using the laboratory for both research and learning. All users must comply with SOP's standard operating procedure, such as filling out a list of equipment borrowings to the laboratory assistant and checking the condition of the equipment before.
The Basic Physics Laboratory is one of the laboratories in the physics department that serves students from all departments in the Faculty of Mathematics and Natural Sciences. One of this topic is Newton's second law. In this practicum, students are required to use pulley system to investigate the acceleration of a moving object. Students need to analyze the coefficient of static and dynamic friction between two surfaces in the system. All the activities in this laboratory have a purpose to prove fundamental theories in physics with simple apparatus. Basic Electronic Laboratory is one of the laboratories in the Department of Physics, which has a purpose to introduce our students to electronics apparatus and circuits. One of the tools often used in practice is the analog oscilloscope and arbitrary function generator that known as AFG. Students must calibrate both the oscilloscope and the AFG before they use in practicum. The amplitude of the calibration signal must match that indicated on the calibration oscilloscope. Mechanics laboratory is sub-laboratory of experiment. Different to basic physics laboratory. In this laboratory, students use more advanced tools in their experiment, which is based on sensor and computer. For example, students use air-track photogate timing system for investigating the force acting on an object based on Newton's second law. Data retrieval is carried out on continuous glider mass value to get the object's speed when it passes through the two photogates. The length between the two photogates obtains the acceleration of glider. The average acceleration could be obtained from the data collected on the computer. Another sub-laboratory of experiment is electromagnetic laboratory. In this laboratory, students can do experiments related to electromagnetism, such as charge-discharge capacitors. In this experiment, students investigate the capacitancy of the charge-discharge capacitor based on the graph of the relationship between voltage and current for various components. From electromagnetic laboratory, we move to optical and wave laboratory. In this laboratory, students can do experiments related to optical and wave theories, such as sonometer. These experiments aim to determine the tension, string length, linear density of the strings. The driver and detector coil can be placed anywhere along the string. With a dual trace oscilloscope, students can examine resonance frequency on the string vibrations. Moving to the modern physics laboratory. In this laboratory, students can do experiments related to the photoelectric effect. The metal plate in the photodiode is illuminated with various frequencies of light, selected from a mercury lamp using filters. The voltage is then adjusted to stop the photoelectric current. The stopping voltage is plotted versus the frequency. and Planck constanta is determined from the slope of the graph. Next is thermodynamics laboratory. This laboratory focuses on experiments related to the laws of thermodynamics, such as the cycle of the heat engine. In this experiment, students determine the efficiency of a heat engine. A heat engine consists of air in the cylinder that expands when the attached can immerse in hot water. The expanding air pushes the piston and acts by lifting the load. The result of this experiment is a graph of the relationship between pressure and volume observed on a computer screen. Another tool is cyclic voltammetry in the laboratory of characterization. The 3000 Cambridge features pulse voltammetry measurements. In this laboratory of characterization, students use universal dummy cell for calibrating the Grammy instrument before conducting cyclic voltammetry tests. The result is a voltammograph graph which shows the relationship between voltage and current. The material laboratory is part of research laboratory in physics department. Students may conduct research to finish their thesis project in this laboratory. One of the tools used in this laboratory is the electrospanning tool, NACRIP 601. This tool has a high voltage power supply, shrink pump and shrink drum collector, camera and LCD monitor, silica gel, humidity and temperature sensors. The electrospanning process result can be used in the medical field and as a filters. The instrumentation laboratory is part of research laboratory physics department. In this laboratory, students may create instrumentation components and design apparatus based on microcontroller system. For example, this tool is a 3D printer. There are 4 steps involved in using 3D printer: design preparation, setting 3D printing applications, setting the density and speed of 3D printer, and printing objects. The 3D printer engine will automatically perform the calibration, heating the nozzle, and bed according to what is preset on the computer. Physics laboratory is part of research laboratories in physics department. Areas of research in the disciplines include understanding of geological hazards, such as tsunami dynamics, earthquake, and volcanic eruptions. Research in this laboratory use secondary data collected from reliable sources such as meteorological, climatological, and geophysical agencies, both Indonesian and overseas. The laboratory is equipped with learning aids suitable for science and physics education students, as well as postgraduate students who wants to do research in the discipline for their final projects. The activities in this laboratory involve intense discussion between lecturer and students that interested in investigating into some salient points of how crustal rocks deep down inside the earth move, relative one layer to another, releasing a huge amount of seismic energy through a mechanism called earthquake.